Hello and welcome. My name is Zaid. I'm an ethical hacker, a computer scientist, and I'll be your instructor for this course. In this course, you'll learn how to become an ethical hacker from scratch. So we'll assume that you have no experience in ethical hacking, and by the end of it, you'll be at a high intermediate level. The first section of this course will teach you how to create your own lab so that you can practice ethical hacking on your own computer. You'll learn how to install Linux systems, interact with them, and set up other systems to try and hack into them. Then we're going to move into our four main penetration testing sections. In each of these sections, the first thing that you're going to learn is how that particular system works, and then we're going to learn how to test the security of that system. So, for example, in the network penetration testing, the first thing you're going to learn is how networks work, how devices interact with each other, and then you're going to learn how to try and hack into these devices and into networks. So you're going to learn how to control all the connections around you. You'll learn how to set up a fake access point and lure people into connecting to it so you can capture all the data they send or receive. You'll also learn how to get the password for any Wi-Fi network, whether it uses WIP, WPA, or WPA2 encryption. You'll also learn a very large number of powerful attacks, which will allow you to gain access to any account accessed by any computer in your network. You'll be able to get usernames, passwords, images, pictures, anything that computers on your network send or receive, you'll be able to capture it. Once we're done with that section, we're going to move into the gaining access section, in which you're going to learn how to gain access to computer systems. So we're going to learn it based on two methods: server-side attacks and client-side attacks. In the server-side attacks, we're going to learn how to discover weaknesses into programs installed on the target computer and use those weaknesses to gain full access to that computer. Then we're going to move into the client-side attacks, in which we're going to be luring the client using social engineering, creating undetectable backdoors or backdoors that look like images or pictures. You'll also learn how to gain access to any computer if that computer exists in your network using fake updates or using fake downloads. Once done, we're going to move into the post-exploitation section, in which you're going to learn how to control the devices that you already hacked. So we're going to see how you can open the webcam, manage the file systems, download or upload files, capture all the key strikes that the person enters on their keyboard, or even use that computer in order to gain access to other computers. So we're going to use that computer as a pivot. Then we're going to move into the last section of our penetration testing sections, which is going to be the website penetration testing. You're going to learn how to gather information about websites, very comprehensive information, and we're going to see how to discover and exploit a large number of very serious vulnerabilities. Once done with each of these sections, you're going to learn how to protect yourself and how to protect your systems from the attacks discussed in these sections. In the next few lectures, I'm going to show you how to install the needed operating systems, the needed programs, and I'm going to teach you some basics about hacking and about how to use these operating systems. So before I do that, I'd like to give you a teaser or a taste of what you're going to be able to do at the end of the course. So in this video, I'm going to give you an example of hacking this Windows computer from this Linux machine. Now, don't worry about how I installed these machines and how am I going to run these commands. Right now, I'm just giving you an example. In the future, I'm going to break this step by step, and you're going to learn exactly how to run this attack and how does it work and how to secure yourself against these type of attacks. And again, this is just one example. During the course, you're going to learn a large number of methods to run a lot of very powerful attacks. So in this example, I'm going to use a program called Beef, which is a browser exploitation framework. I'm going to launch it from here. And the way this works is it uses a JavaScript code to hook a target computer, and then once a computer is hooked, we'll be able to run a number of commands. Now to do that, I'm going to use a man-in-the-middle attack to automatically inject the hook code for Beef. So I'm going to use a tool called man-in-the-middle-f, and I'm going to do an ARP spoofing attack, and I'm going to give it my network interface, and I'm going to give it the gateway, and I'm going to give it the target IP address, which is the address of the Windows machine. Then I'm going to tell it that I want you to inject a JavaScript URL, and I'm going to give it the location where the hook code is stored. I'm going to hit enter. And that's it running. Now I know this looks very complicated, you don't know where I got the options from, all of this looks confusing, but again, don't worry about that, we're gonna talk about this and go through this step by step so it'll be very easy for you. Right now, all you need to understand is this program is going to inject the hook code, so the code that allows Beef to hack into that computer, into the browser of the target person, so that the code will run without the person even knowing. So I'm gonna go to my Windows machine, I'm going to run the web browser, and I'm just going to go to any website, so I'm just going to go to bing.com. Now if we go back to the Kali machine, you'll see that we have the IP address of the target person under the hooked browsers. And if we click on the commands tab, you'll see a large number of categories with commands that you can run on the target computer. Again, we'll talk about that later in future videos. What I'm interested in is a plugin which allows us to show a notification bar on the target computer. And what I'm gonna say in that notification bar is I'm gonna say that there is a new update. Click here to install it. So what this is gonna do is it's gonna show the target person that there is a new update, and once they install that new update, I'll hack into their computer. Now, to do that, I'm going to have to use a backdoor. Now, I've already made a backdoor that's not detectable by antivirus programs. I'm not going to show you how to do that now, but in the course, you'll learn how to do that. So right now, I'm just going to say where I stored the backdoor. And I called it update.exe. So that's it. That's all done. I'm going to click on execute. And that will execute it for me. Now, before I go and run the update, I'm going to listen for incoming connections so that I can connect to the target computer once they try to update their computer. So again, I'm going to explain why we need to do this and how to do this in future lecture. Right now, I'm just going to do it very quickly. And once we do that, if we go on the target machine, you'll see that their Firefox is telling them there is a critical update, and you need to click here to install that update. I'm going to click it, and you can see that it's downloading an update file for me. I'm going to save it, and then I'm going to run that update. And once we do that, if we go back to the Kali machine, you'll see that we managed to get a reverse session from the Windows machine. So I'm going to interact with that computer, and now I'm inside it. So I can do so many things with the target computer. I basically have full control over that computer. And we're going to talk about all the things that you can do in the post-connection section of this course. What I want to do now is I want to show you how to access the webcam of the target computer. So we're going to use a plugin that comes with Meterpreter. So I'm just going to do webcam stream. I'm going to hit enter. And as you can see, I managed to turn on the webcam of the target computer. So this is actually a webcam that's attached to the Windows machine. And right there, you can see me, and I basically hacked into the Windows machine. I can do anything I want on the Windows machine. And I can also turn the webcam. I can inject a keylogger. I basically have full control over that machine. Now again, this is just an example of one attack that we're going to use. We're going to do so many more attacks like this, and all of them are going to allow us to gain full control over the target system. So don't worry about how to do this attack, don't worry about the commands, don't worry about all of that. This is just a teaser, a simple taste of the things that you'll be able to do by the end of the course. Okay, so what is hacking? Hacking is being able to do anything that you're not allowed or supposed to do. So for example, viewing any page that you don't have permission to, viewing information that you don't have permission to, or even hacking into a computer or gaining access to any other computer. You're simply just controlling or using another computer that you're not allowed to use. So there's so many different types of hacking. So you have email hacking, computer hacking, server hacking, web application hacking. so many different types of fields. Anytime you manage to do something you don't have permission to, then that's hacking. So there is three different types of hackers. We have black hat hackers, white hat hackers, and gray hat hackers. The black hat hackers are ones that hack into systems for their own benefit. So these are the ones that steal money or break systems just for their own benefit. Then you have the white hats who try to secure systems. They might use the same methods used by black hat hackers, but they'll only do it on systems that they have permission to. So they only do it in order to see if these systems are vulnerable so they can actually fix these systems. And we also have gray hat hackers, which are like a mix of the both. They will test any systems they want, even if they don't have permission to hack into networks or systems. They'll try to do it anyway. But once they do hack into things, they'll not break anything. They won't steal any money. They won't cause any damage. They might even tell the administrators how to fix it. So in this course, we're actually white hat hackers, and I'm only teaching this for educational purposes only, and for people who want to be able to secure their networks and who work as or want to work as pen testers so they can secure computer systems. So hacking is an existing field. There's so many job opportunities, and it's happening. There's a growing demand on it. It's happening every day. We all heard about the Sony hack when PlayStation was down for a considerable amount of time. So companies like Sony and all of them are actually hiring people to try and hack into them. So you're gonna learn how to try and hack into these networks and these systems so that you can secure them, so that you know how the black hats use these vulnerabilities and weaknesses and secure yourself against them. Not so long ago, someone found a way of brute forcing the restore password key when you restore your password with Facebook, because Facebook didn't check for the amount of times that you enter a wrong PIN. So someone found a way to brute force that on the mobile website and then gain access to any Facebook account. Once they did that, they actually told Facebook about it, and they got rewarded $20,000 because Facebook has a bug bounty program. So many websites and companies at the moment have bug bounties in which they're actually asking people to go in and try to hack into them. And if you manage to do it and tell them how to do it, then they'll actually pay you an amount of money depending on how dangerous the exploit is. So as described earlier, the course is going to be highly practical. So in order to be able to do that, we will need a lab, a place where we can learn and perform attacks against. So to do this, we're going to use a program called VirtualBox. Now, VirtualBox is a program that allows us to install machines just like normal computers inside our own machine. So I have one computer and I'm going to install other computers inside this computer. So they're gonna be virtual machines. Now these are very important in terms of penetration testing. We're gonna be using them a lot to set up the lab. Now it's very important to note that a virtual machine is just like a completely separate working machine. There is nothing you're going to lose by installing an operating system inside a virtual machine. The operating system will perform just like installing it on a separate laptop. So basically, instead of having 4 or 5 computers or laptops around us so that we can try and hack into them, we're going to install these computers as virtual machines inside our own machine. This might be a bit vague now, but once I do it, it's going to become very clear to you how this is going to work. So basically, I'm going to have 3 computers inside my main computer. So I have my main computer, which is Mac OS, and I'm not going to do anything on that. That's just going to be my computer that I record the videos from. Now I'm going to have a machine. That's going to be my attacker machine, and that's going to be a Kali Linux, and I'll talk about what Kali Linux is once we get to that. And then I'll have 2 victims. I'll have a victim that runs Windows right here, just a normal Windows machine. And then I'll have a victim that runs an operating system called Metasploitable. And I'll talk about what that is. So basically, we're going to have our own machine, and then we'll have 3 separate machines inside this main machine. The 3 separate machines are the ones that we're going to use to carry out the penetration testing attacks, and they're going to be Kali Linux, which is the one that we're going to use for attacking, and 2 victim machines. Now all of this is going to be possible because of the program that I told you about, which is called VirtualBox. Now VirtualBox is free and you can download it from the following link. Now I'm going to show you right here. If you just go into, if you literally just Google download VirtualBox, and we're just going to go for the first link right here, and just grab the version that's compatible with your operating system. So there is VirtualBox for Windows, and here is for Mac OS X and for Linux. So just download the VirtualBox version that is compatible with your operating system, double click it and install it. Installing it is very simple, very easy. You literally just, even for Linux, you double click it, click next, 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 and it's installed. Now I have that installed and ready. Now this is my VirtualBox. As you can see, it's installed and I have no machines right here. Now in the next few lectures, we're gonna learn how to install Kali Linux and the two victim machines, and I'll talk about what each of these machines does and why are we gonna use them. Now throughout the course, we're gonna be using a number of penetration testing tools. You can go ahead and install each of these tools manually, or you can do what most pen testers do, including myself, and save time and effort and use an operating system designed for hacking. We're going to be using an operating system called Kali Linux, and it's just a flavor of Linux based on Debian, and it comes in with all the programs and the applications that we need to use pre-installed and pre-configured. This means that we can just install this operating system and then start learning or hacking. There are two options to install Kali. You can install it as a virtual machine inside your current operating system, or you can install it as a main machine, as a main operating system. Throughout the course, I'm actually going to be using it as a virtual machine because using it as a virtual machine works exactly the same as installing it as a main machine, because it will be completely isolated from your computer because it's only going to run inside VirtualBox. So if you break it or if you mess things up, it's very, very easy to fix. It's very easy to go back to other snapshots, other configurations, and also you won't lose any functionality by using it as a virtual machine. That's why I always use it as a virtual machine. And in this lecture, I'm going to cover how to install it as a virtual machine inside VirtualBox. Now I'm going to be doing the steps on a Mac OS X computer, but these steps are exactly the same regardless of what operating system you use. So if you're on Windows or on Linux, you just have to download the VirtualBox version of your computer, and then the steps shown in this lecture are exactly the same after installing VirtualBox. So I'm going to include the download link in the resources of this lecture, and I have it already opened in here. All you have to do is just scroll down. Make sure you click on the Kali Linux VirtualBox images, not on the VMware, and then download the version of Kali that's compatible with your system. So if you have a 64-bit computer, download the 64 bits. If you have the 32 bits, download the 32 bits. Now one click on this will start the download for you. If you're using Internet Explorer or Edge browser, then you're going to have to right click and save target as. On Chrome and Firefox, you can just click the link. Now this is downloading for me and I'm going to stop it because I've already downloaded it. So I already have it downloaded in here. And as you can see, you should get a file with a .ova extension. So you have the name followed by .ova in here. So to install this in VirtualBox, all you have to do is literally just double click the file. And as you can see, I get a window which will allow me to import this virtual machine. Now I'm going to keep everything the same for now, and I'm just going to click on import. Now that's it, the virtual machine is ready to be used. Now before I start it, I want to show you how to modify some of its settings. So we're going to click on it. Then we're going to click on the settings in here. And the first thing that I'm going to do, I'm going to go to System. And I'm going to modify the amount of RAM it has. Now depending on how much total RAM you have on your computer, you can leave this at 2 if you want. But 1 GB is enough for Kali. I usually leave it at 2 because I have 16 gigs of RAM, but if you have less, 1 GB is enough for it. Also, if you come here on the processors, you'll see that by default I have 2 processors assigned to it. Again, I have 8 CPUs, so 2 is not gonna cause too much pressure on my computer. If you have less, 1 CPU is enough for Kali. Now, we're gonna go to the network settings, and we're gonna set this to use a NAT network. Now, sometimes when you set this to a NAT network, you won't see a network name in here. If you don't, please check out my link in the resources and it'll show you how to create a NAT network. For me, it already has a NAT network, so I'm going to keep it on this one. And what this setting basically does is it's going to create a virtual network where my host machine, which is my Mac OS X computer in here, is going to be the router for this network. And then all the virtual machines are going to be clients connected to this network. So they're going to get internet connection from my host machine, and at the same time, all of my virtual machines will be connected to a virtual network. This is very handy because my virtual machines will be able to communicate with each other. We can use one of them to hack into the other. We can use it to test network attacks and much more. So it'll first allow my virtual machines to have internet connection. It'll also allow them to communicate with each other. And it'll do all of this through a virtual network. It will not use any of your wireless adapters or any of your wireless cards. It'll create a virtual Ethernet network. So as far as the virtual machines concerned, they're going to think that they're connected to a network through a wire. So that's it. I'm done with my settings right now, and I'm going to click on OK. And we can start our virtual machine. Now to start it, all we have to do is just click on the start button in here. Now I'm going to click inside the virtual machine and hit enter. And we are inside the virtual machine. Now it's asking us for the username, and the default username is root, so ROOT. And then it's asking us for the password, and the default password is the reverse of that, which is TOOR. And that's it. Now I'm inside my virtual machine. Now, since we installed this using the ready image, we can just click on this on the green button here, or we can go to view full screen, and we'll be able to go in full screen, and the screen will resize automatically to the size of our screen. Now note in here, you should actually see a network icon because we set this machine to use a NAT network. Since we don't have a network icon, this means that this machine didn't get connected to the NAT network. So if I open my browser in here, you'll see that it's not connected to the internet. To fix this issue, we're just going to go all the way to the top. This is going to display our menus. We're going to go to Devices, Network, and we're going to click on Connect Network Adapter. You only have to do this once, and then the virtual machine will automatically connect to the NAT network. Now once you do this, if you give it a few seconds, you see that I have a network icon appearing in here. And if I click it, you'll see it looks like I'm connected to a wired network. As you can see in here, it says wired connected. So Kali thinks it's connected to a wired network. Now if I just click try again in my browser, you'll see that I have internet access. So that's it. That shows how to install Kali Linux as a virtual machine. Don't be intimidated by this new operating system. We're going to go through the basics and we're going to use it a lot. And it's actually going to become very easy for you to use. Also, like I said, you won't lose any functionality when you install Kali Linux as a virtual machine. It's actually better to install it as a virtual machine because it's completely isolated from your computer and it'll be very easy to fix if things go wrong. Keep in mind, installing this on different hardware and different computers might show you some errors and some issues. So please, if you have any errors, just add them in the discussions and I'll help you resolve them. Okay, so after installing Kali Linux, we're going to proceed to installing the second machine in our lab. So the second machine is going to be Metasploitable. Metasploitable is another Linux machine. You can think of it as the opposite to Kali. So Kali is designed so that you can use it to hack into other devices. Metasploitable is designed so that you hack into it. So it's designed for people who want to learn penetration testing. It is designed so that it has a number of vulnerabilities, and we're going to try to use Kali Linux in order to hack into Metasploitable. So this is going to be one of the target or victim machines. You can download this from the following link. You will end up with a zip file like this one. So, sorry, not this one, like this one. So once you uncompress it, you'll get this directory. Double click it and you'll see the following files. So we're going to create a new machine here in virtual machine, and I'm going to call it Metasploitable. And this is going to be a Linux machine. And I'm going to hit continue. And I'm only going to give it a gigabyte of RAM, should be enough. And then I'm going to use, remember with Kali Linux, we created a new virtual hard disk. With this, we're going to use an existing one. The reason for that is because the image that we have right now is actually, it's designed for VMware Player. So what we're going to do is we're going to import the hard disk file or the hard disk image in here, so that we're going to have a ready installation without having to install it the way we installed Kali Linux. So we're just going to use an existing virtual hard disk file, and I'm just going to navigate to select what it is. I'm going to go into the Metasploitable directory, and I'm going to select the .vmdk file. So it's this file right here. I'm going to click on open and create. So we're going to start this machine right now. Okay, so the machine has run now. It's completely installed. As I said, you don't really need to install anything. We just imported a ready installation, a ready hard disk. So it's asking me for the username, and the username is msfadmin. And the password is the same, so it's msfadmin as well. And as we can see now, we logged in. Now this machine only has a terminal, as you can see right now. And it's giving you a warning that you should never expose this machine to external internet connection, because it is a vulnerable machine. It is designed to be vulnerable. Now, right now, it's only inside our lab. It's only installed as a virtual machine. So literally nobody outside our lab can access it. So this is a really good way of using it. Now this is it, the machine is installed. As I said, in the future, we're gonna talk about how we're gonna try and hack into this machine. Again, don't be intimidated by the terminal. We're gonna be using it a lot, and we're gonna learn how to use it step by step. So at the moment, we have this installed, and we're gonna move on to the next step, and we will talk about this once we actually need to use it in the future. So if you wanna turn off this machine, all you have to do is just type in power off, and hit enter. And it's telling you that you need to be root. So again, I'll talk about this later. For now, sudo power off. So just run the command like this. And it's asking you for the admin password. And that's it, it's going off now. And here we go, the machine is off. The last machine that we're going to talk about installing today is the Windows machine. So this is just a normal Windows machine that with Windows 10 that we will also try to hack into. So this is going to be another victim, another target, and we're going to see how we can try and hack into this victim. Now, again, we installed Metasploitable because Metasploitable has a large number of vulnerabilities, and it's just designed so that you can hack into. Again, we've seen that it has a terminal. It's not very user friendly, as in it doesn't really mimic a normal user. For the Windows machine, this one will be used with scenarios that mimic a normal user that is just using their Windows to browse the internet or do whatever normal people do with their machines. So Microsoft has actually released a free versions or free virtual machines of Windows that you can download and use. These are free and you're allowed to download them, and we're downloading them from Microsoft's website. So you need to go into this link to download it. As you can see here, this is the same link. So make sure you select what host operating system you have. So if you have Windows, you click on the Windows tab. If you have Mac, on the Mac, and if you have Linux, on the Linux. I have a Mac, so I clicked on the Mac tab. And from here, make sure you select Windows 10 Stable. And make sure you select the VirtualBox image. So these are all applications that allow you to install virtual machines. At the moment, we're using VirtualBox for everything, so just make sure you use the VirtualBox image. Once you do that, you will have a zip file like this one. Uncompress it, and you will get this file right here. Now, this is a virtual machine, a VirtualBox virtual machine file. So I'm gonna double click it. And as you can see now, VirtualBox is asking me to import this machine, and it's already set up the settings for it right here. Now we can import it the way it is and then modify the settings. Now, as you can see here, I have my Windows installed right here, and I'm just gonna boot into it by, actually I'm gonna modify the settings first, because I remember I think it gave it 4 gigs of RAM, and I think that's too much. So I'm gonna go in to here, and I'll set this to 2 gigs. And yeah, and set that okay. And I'll start it. And as you can see, Windows starting straight away. No need to install it. It's already installed and ready and given to us by Microsoft. Now, as you can see, we have a fully working Windows machine right here, Windows 10. And this is going to be our third machine that we're going to use in our lab, and it's going to be our second attacking machine. So it's our second victim or target machine. The Kali Linux machine is the one that we're going to be using to attack both of these machines, the Windows machine and the Metasploitable machine. Now that we created our virtual machines, it's a really good idea to take snapshots of them. A snapshot allows you to store the state of the current virtual machine. So it allows you to go back in time or go forward to a certain state after you go back. So you can think of it as bookmarks. For example, now we can take snapshots of our fresh installation of the operating systems, and in the future, if we update or configure something or break something, you can literally just go back to the fresh install or go back to factory settings if you want to call it. Then, if you did something there and then you wanted to go back to your updated system, then you can go back to the updated system as well. So you can literally take a snapshot whenever you want to store the state of the machine, and then you can go back and forth between these states. Now I'll show you how to do that. I have Kali Linux right here, the one that we installed, and it's very easy to create a snapshot for it. All you have to do is just go on the snapshots here and click on the camera icon. Then it's going to ask you to call this snapshot something, so I'm just going to call it fresh install. And I'm just going to give it a description saying it's a fresh snapshot with no updates. It's always a good idea to give a good name and good description so that in the future you can actually remember what these snapshots stand for. So now that I'm done, I'm just going to click on OK. And now you can see that we have the current state. So whatever you do in here, you can update, you can install programs, you can install libraries, and then if you break something or if you ever wanted to go back to the fresh install, you can just come back, click on the fresh install and restore. So let's see now. I'm just going to go back to the details as normal, and then we're going to start our virtual machine. I'll just show you an example now. So let me just create a new directory in here. And I'm just going to call it test. So let's imagine that you actually updated the system. Now in the future, we're going to talk about updating the system. And I'm going to tell you that when you update, there is a good chance that some libraries, some programs will not be as up to date as the libraries that will be installed. And then these programs might start giving you issues. Now, if you had the issues, you can put them into discussion and then I'll help you with them. But some cases, I'll tell you that you need to go back or downgrade to the older version without the update. So all you'll have to do is just get back to the fresh installation to your fresh snapshot. So now I've just created a new file just to show you that once you actually go back, everything will go back to the way it was before the changes that you made. So I'm just going to turn off Kali. And now if we go back to the snapshots, you'll see that we have our current state. This state have been changed, so it's a changed state. Now let's say that you updated and the update was successful, so nothing was broken and you are happy with it. So what you should do is you should just come in and click on the camera icon again to create another snapshot. And we're going to call this one updated system. And then you can just put the date if you want to. And then I'm just going to put the description updated with no problems. So I'm going to click OK. And you can see that we have two snapshots. We have the first one, which is our fresh install. And then we updated our system and we have an updated snapshot of an updated system. So now let's say that after you updated and you thought everything is okay, you are using the machine and you have problems, so you wanted to go back to the fresh installation. All you have to do is just click on the fresh install and you can see that the restore icon right here. Just click that. It's going to ask you, do you really want to do that? I'm going to say yes. And now it restored me to the fresh installation. So now if I start the Kali machine, you'll see that the new directory that we created will disappear. Now as you can see, we're back to where we were without the new directory, without anything. So we are actually back to the fresh installation of Kali, to when we actually took the snapshot. So now I'm going to show you another example. So let's say you went back in time and you went back to your fresh installation, and then for some reason you wanted to go back to your updated state to see if you can fix the issue. If I suggested the solution, or if you read the solution online and you want to go back and fix the issue that you had after the update, or for any other reason, maybe you just wanted to go back to a different state. It wasn't an updated state. I'm just giving an example with the update. So if you want to go back to a future state, you can still do that. So all you have to do is just again click on the updated, click on the restore. And we don't want to create a new snapshot from the current state because the current state is the updated state. So we're going to restore this, start the machine, and you'll see that we'll be back to the updated state to where we had the new directory created. So we're actually going to go back in the future now. And as you can see, now we have our test directory. So we're back to the state where we updated the system. So again, as you can see, the snapshots can be really useful. They can allow you to store bookmarks or states of the operating system. So you can actually have different configurations and you can switch between them as you want. It's also really useful if you installed Windows as well as a virtual machine, because the way I showed you when you install Windows, it actually gives you a trial version and it might start complaining about it in the future. So if it does, you can just go back to your fresh installation of Windows and you'll be back from as if you just installed it on that day. So I suggest you go to your VirtualBox now and take snapshots of all the machines that we installed so far. Right. Now that we have Kali Linux installed, let me just show you an overview of the system, what Linux is, what's the structure of the file systems are, and some of the basic apps that we're going to use. Now, bear with me. I know the quality of the Kali here right now. I'm using it in a stretched mode, so it's not proper full screen. I'm doing that because there is certain programs that we need to install first to make it support the full resolution of the screen or of the monitor. I'm gonna talk about that in the next lecture because it's not advanced, but it's just you need to know some commands and I'll walk you through them. But for now, I'd just like to give you an overview of the system. So as you can see here, we just have a status bar, very simple. The applications menu can be accessed from here. So if you click on applications, you'll be able to access all the applications that come in pre-installed with Kali Linux. And as you can see, they're divided into categories in terms of the type of the attack that they allow you to do. So we have information gathering, vulnerability analysis, web applications and databases, exploitation, reverse engineering, all types of applications that can be used for penetration testing. In the places here, that allows you to access your file systems, the files that you'll be using. It's something similar to My Documents in Windows machines. So as you can see here, if we click on computer, you'll be able to access all the files and the devices. You rarely go here. You usually access stuff through the home right here, or through the root, because we're the root users. So it's the same thing if I go to places and then go to home right here. And from here you can see that you can access your desktop, your documents, downloads, music, whatever. Same way that you have it for Windows or for Mac OS X. And again, you have your trash here where your trash goes. This is just a basic file manager, back, forward, and then you can double click a file to run it or double click a directory to open it. Here we have, again, as I said, the status bar. Here you can see the number of desktops or workspaces. Now, Linux usually supports workspaces, so you can have different windows running on different workspaces. Now, at the moment, I have no windows running, so I can't really go to the second workplace. But for example, if I had my file manager open here, I can go to a next workspace, and will be empty, and then I can have something else running here and have 2 things or 3 things. I can have as many workspaces as I want, and it's just easier for you to be switching between them, and we'll be using them when we're doing our penetration testing attacks. Now in here you can have your keyboard if you have more than a keyboard that you want to switch between them. You have your networks from here, so you can access your wired networks and your wireless. Now one thing to note, you will not be able to access your internal wireless card through a virtual machine. So the internal wireless card that you have, which is connected to your main machine, you will not be able to access it through your virtual machine. As you remember, we set the settings of this computer to be connected through NAT, which means that it has internet connection, but the internet connection is coming from the host machine. So it actually has a virtual network set up between this device and my main device, which is this device. So there is a connection between the 2 devices. This device has internet access because of the internet access provided by the main machine. You can also change your volume from here, from the same menu. You can turn off the computer, lock it, or enter the preferences from here. These are just normal preferences. You can get yourself familiar with them. Backgrounds, notifications, displays. We'll play with this after we fix the resolution. Mouse, networks, all that kind of stuff. And then you have your battery settings, and that's it really for the status bar. So very simple. Applications and places, the most things that we'll be using, and then you can access your network settings from here. If you had a wireless card connected, you'll be able to see the available networks here. If you want to connect a wireless card, all you have to do is connect it. So I have a USB wireless card. I'm going to connect it now, and I'll show you how it shows up. So you need to go to this menu right here, devices, and then go to USB. Now this procedure is the same regardless of the device that you connect. If it's a USB device, whether it's a wireless device or if it's just a memory stick or any USB device, you go to devices, USB, and then select the device that you want to connect. So I connected a wireless card, and the chipset that's used in the card is called Atheros. So this is my wireless card. I'm gonna click it, and that should connect it now to my virtual machine, to the Kali machine. So if we go here and go on wireless and then select a network, and as you can see, I can see the networks that exist around me. I can select any network that I want to connect to and just put the password and connect to the network normally, the way you connect to any other network that you want. Okay, so I'm going to disconnect my wireless card now. Now, as you can see, now I don't have a wireless card connected. What I'd like to note though, I still have internet connection because, as I said, my main machine right here, the Mac OS X machine, is connected to my network, and this virtual machine is connected to my Mac machine via an internal virtual network. So the browser that comes in with Kali Linux is this one. And I'm going to just go to Google to show you that we have internet connection. As you can see that we have internet connection right here. Now this is just a normal browser. You can use it the same way you use any other browser. The applications right here, I'm not going to talk about them at the moment because we're going to use them in the future, and you'll see what each one of them does once we get to it. Okay, so now I'd like to show you and give you an overview of the Linux terminal. The terminal is a place where you can basically do anything you want on the operating system and run any program you want on the operating system by running the commands that are associated with the action that you want to do. The Linux terminal is very powerful, and it basically allows you to do so much more than the graphical interface. A lot of the programs that we're going to use have graphical interfaces, but the command line is just so much easier, so much quicker. Also, in many scenarios that you'll face in the future, you might just get an SSH or a command prompt on the target computer. Therefore, you need to know the commands in order to be able to do whatever you want it to do on a computer or to pen test its security. So learning the command prompt, learning how to deal with the command prompt is very important. We're going to be using it a lot through the classes. So for now, I'm just going to give you a very simple overview. And as we use it, I'll be talking about more of the features. It's just going to become so much easier for you. You're going to love it. It's going to be so much easier than running through the graphical interfaces. So using it is very simple. You literally type in the command and the result is displayed on screen as text. So let's have a look on a very, very simple command. The command is called ls. And what this command does, it lists all the files and directories that exist in the current working directory. So it's similar to the dir command in Windows machines. Literally just lists all the files and directories that exist in the current directory. And as we can see, the files and directories that we have now are desktop, documents, downloads, music, whatever. Now, before I just go more into detail of other commands, one of the very important commands that's going to become so handy to you in the future is the man command, M-A-N, and it stands for manual. The man command can be used to query and get the manual of any other command. For example, we just used the ls command to list all the directories that exist in the current working directory. Now, let's do man and then type in ls after that. This will show us the manual for the ls command. And as you can see that it's telling us that the ls is used to list contents because it lists files and directories. And then we can see that this command actually takes options. So it takes more options than just the ls command. And you can see the format of the options in Linux. It's either a minus letter, abbreviation, or minus minus, and you type in the full option, which is all, for example, in here. And then right here we can see that what this option does. So for example, the all option, it does not ignore entities and starting with the dot. So if you type in on enter, the manual will just keep going down so you can read more stuff. And as you can see that these are all the options that you can do with the command. You can see, for example, here the -L uses long listing format. So let's quit this. To quit this, you just type in Q and we're out. So we're out of the manual for the ls. And let's run ls with some options. So I'm going to do ls and then I'm going to do -L, and that's the one that will show us more information about the files. So it's basically the same command that we ran before, but as you can see now we got more information. We've seen the total entities that exist in the current working directory. We can see the same directories that we've seen before right here, but we can also see the dates that they were created or modified. We can see the user who is responsible for them, and it's the root user. And we can also see the permissions on these. Now we're going to talk on permissions in the future as well. Basically, permissions specify which users can do what. So they go into read, write, execute, read, write, execute. You don't really need to worry about them now. We'll talk about them more in the future. And this is just an example of the ls command. Now, all of these commands are not hacking commands. They're not penetration testing commands. They're just commands used in Linux that allow us to do different things on the operating system. Now, you can do penetration testing commands, and we're going to do them in the future. And they're literally just running programs on the operating system. Another really useful option is the -- help. So I'm going to do ls again and do a -- help. Now the man and the -- help work on almost every command. So you can do man ls or ls -- help, and it will also always show you help or the manual page of the program. So right here we can see this is the help page of using the ls, and it tells you all the options again of the ls command. So again, it's a minus or minus, and then you put the option name like we did before. And on top, it shows you information about what the command does, and it gives you the format of the command. So it should be used in this particular format, usage ls, and then you put the options, and then if you want to do anything to a file. So it's very similar to the man command. Sometimes some programs will not have the man, so they'll just have the help. So if you have any command, if you have any program that you're not sure on how to use, you can always just type in man, the name of the command, or the name of the command -- help. Another useful thing with dealing with terminal, you can press the up and down arrows to go through the history of the command. So as you can see, I'm switching between the commands that I ran. I ran man ls, I man lsl, I man ls -- help. So I can switch between the commands through the up and down. Another useful thing is the tab button on the keyboard. So if you're typing a command, or if you're looking for a file and you're just not sure, for example, let's say I want to type a file name. Let's first make a file. So I'm just going to go to places, home, because right now we're in this particular place, and I'm going to create a new, let's create a new folder. So let's say I'm looking to do something with test. So I'm looking to go into the test. So the cd command can be used to go to change the working directory, to go to another directory. And let's say I want to go into test. So if I just type in te, and I'm lazy, so I'm just going to type in tab right now. And as you can see, it automatically finished the directory because there is no other directory that starts with te, and it's just going to take me to the test. And as you can see, now I am in test. So another useful command right here is pwd, and that shows you the current working directory. And as you can see, now I'm in root test. Now if I want to go back, I can just do cd, again change directory, and instead of typing a directory name that I want to go to, I'm just going to type in ... and that'll just bring me back to where I was, which is in root. So I went back from root test to just root. Another useful command is clear. Just clears everything, and everything is gone now from screen. Now these were just very basic commands. Now there is so many commands on Linux. I'm gonna attach a list of Linux commands with this lecture. Again, every program you install on the system will be installed as will have a command prompt version, so you can access that program through the command prompt. A lot of the programs that we're going to use will not even have a graphical interface, so you have to use them through the terminal. Again, don't be scared of that. We're going to use it in the future. At this class, I just wanted to give you an overview of how the terminal works and how you can deal with that, how you write the commands and what shows up on screen, just to get you more comfortable with the structures, how you go into directories, leave directories, and all that. I don't want to make this too long. As we learn in the future, I'll be talking about features, and everything I do, I'll be explaining it. So don't worry about it. It's going to be very easy. Now that we know how to interact with the terminal and Linux basics, I just want to show you some final steps that we're going to do. I'm going to show you how to update your sources, how to install programs, and how to install a really useful terminal that would be very handy in the future. So, I'm going to go to the Kali machine, and the first thing that I want to show you is viewing the machine in full screen. So just go to View and go to Full Screen, and that will automatically expand everything and put it in proper full screen. The next thing that I want to do is talk about the package manager in Kali Linux. So you can install programs using a command called apt-get. So you usually type in apt-get, and then if you want to install something, you type in install, and then you type the package name that you want to install, so the program name. Before you do any of that, you have to update the sources. So the way that this program works is it works through fetching a number of libraries. So on a fresh installation, you want to update your sources, make sure that it has the latest sources for the libraries and the latest available programs. So we're just going to do apt-get update. This command will not update your system, it will only update the list of available programs that can be installed. And now everything has been updated. Now you can actually go ahead and start installing programs. So I'm going to give you an example of installing a really useful terminal application called Terminator. So, like I said before, the command is going to be apt-get install Terminator. Hit enter. And as you can see now, it's telling me, do I really want to install this? I'm going to say yes. So I'm going to type in Y and hit enter. And this will automatically download the application and install it for me. So now we can go ahead and try to use Terminator. So if we go to all applications here and type in Terminator, you will see it right here. Now I'm actually going to right click it and add it to my favorites, so it shows up in the dock. So we can see it showing up right here. I'm going to click that. And as you can see, it's just another terminal application. I'm just going to increase the size in here, the size of the text. And now you can actually run programs through this terminal, so you can do any commands that we learned before. The cool thing about this terminal is you can actually split the screen and run multiple commands. So if you right click and you can split horizontally, and I can run commands in here and on the top in here. And again, I can split this horizontally or vertically if I want. And then I have 3 windows where I can run 3 commands or 3 programs at the same time. So it just can be really handy. It can make your life much easier in the future. One more command that I'd like to talk about is upgrading your system. Now, in many cases, when you upgrade your system, you might face issues with broken libraries. So some of the programs might not work because the libraries that they depend on will be updated, but the program itself will not be updated. So the program will actually break. So you can try to do this. If it doesn't work, you can restore to a snapshot that you created before. But I usually don't really upgrade. Most of the time I keep it the same way, and if there's a new version of Kali, I just import that as another virtual machine instead of upgrading my existing Kali version. Now if you want to upgrade your system, all you have to do is just type in apt-get upgrade. Now if I hit enter, you'll see that's telling me there's a large number of libraries and packages that's going to be upgraded. If you hit enter, it will start downloading and installing and configuring these packages. It might ask you to configure a few things. Just make sure, just keep saying yes, 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 or set the configurations the way that they're set by default. So don't be very adventurous and try to change things. Keep them the way that they are. Again, most of the time I keep it the same way. If you want to upgrade, then try it, see if it works. If you're gonna have any issues, you can post it in the comments and I'll reply to them and I'll help you with them. And in the future, if any of the programs started giving you errors, I'll tell you if this is due to the upgrade or not. The first penetration testing section in this course is going to be the network penetration testing. The reason why I chose to start with this, because most of the systems and the computers that you're going to try to gain access to will be connected to a network. Whether it's a device, a computer, a phone, simply any device connected to the internet is actually connected to a network. Therefore, you need to learn how networks interact with how devices interact with each other in the network, how networks work, so that you can advance into the future into different types of penetration testing. So first of all, before we start learning penetration testing, we're going to learn how networks work, and how devices interact with each other. After that, the course is going to be divided into 4 main sections. The first section is the pre-connection attacks, and the second section is gaining access. Both of these sections are mostly geared towards wireless networks. The reason behind this is usually with a wireless network, there is protection, there is encryption, so you need to use a key in order to connect to the network. So there's WEP, WPA, and WPA2 encryptions that we're going to learn how to break. And we're also going to see what attacks you can do without having to connect to any network. So if I only had a wireless card, what attacks can I do using that wireless card? The reason why the first 2 sections don't talk about wired networks, because if you wanted to gain access to a wired network, simply all you have to do is connect your Ethernet cable to that network. Now, some wired networks use security, and some of them use MAC filtering. We're going to talk about that, and changing the MAC is going to be very easy, and you're going to learn it in the first 2 sections. So, if you had a wired network, you probably can jump to section 3. If you had a wireless, then you need to go through steps 1 to gain your access, and then you're at section 3. In section 3 is where the fun starts. You're going to learn how to sniff packets from the network, how to control the connections, how to sniff passwords, usernames, cookies, how to inject them into your browser, how to launch attacks that will allow you to gain full access to any device that's in your network, whether it's wired or wireless, and without the person having to do anything who's using that device. So section 3 will apply for both wired and wireless, and it works exactly the same. There is no need for change of configuration. In the last section, we're going to talk about how to secure yourself against all of these attacks and how to detect them. Before we can start trying to hack into networks and break into them, there's a few basics that we need to learn before we can do that. So basically, what is a network? A network is just a number of devices connected together. They are connected together for a reason, so that they can share data. This data can be files, can be resources. It can be, for example, your home network. Usually you use it to just access the internet, which is, you can look at it as a resource or as a source of data. So all networks, Wi-Fi or wired, achieve this sharing of data using the same principle. And that principle is, you need a device that acts as a server, and then all devices communicate with the server. So the server has access to the resource, and all the other devices on the network that are connected to this server, obviously, they can access the data from the server. So on most Wi-Fi networks, the server is the router, and all devices connect to this router, and they access the internet through the router. So all the devices on the network have no access to the internet, as we can see in this diagram. The only device in the network that is connected to the internet is the Wi-Fi router. All the other devices, as we can see here, we have client 1 and 2 and 3, they have no access to the internet, but they can access it by connecting to the router. So whenever client 3, for example, if it wants to open google.com, it's going to send a request to the router asking it, okay, I need google.com. The router is going to go to the internet. It's going to grab google.com and then forward it back to client number 3. So client number 3 does not have direct access to the internet. It has to go through the router, and the router is going to bring the request and send the response back to client number 3. Now all of this data, requests and responses, are transferred through packets. So you can imagine all these arrows are a number of packets being sent between the clients and the router. And in Wi-Fi networks, these packets are sent into the air, so they're broadcasted. And if you're within range with these packets, then you can just sniff them, capture them, and read them, and you'll be able to see the information in there. So all this data, so whether it's usernames, passwords, videos, audio, music, chats, all of that is transferred as packets, and it's always transferred between the client and the router because the client has no access to the internet. So if you capture these packets, you'll be able to see all of this data that's transferred. You'll be able to see all these passwords, usernames, emails, videos, all that. You'll be able to capture it and read it on your device. In this lecture, I'm going to show you how to connect a USB device to a virtual machine. As an example, I'm going to be connecting a wireless adapter to my Kali machine. But the same method can be used to connect any USB device. Now, as mentioned in the course requirements, you need a wireless adapter for the cracking section of this course. So these are the lectures where we're going to show you how to crack the passwords for Wi-Fi networks. Other than that, you can do everything else in the course without a wireless adapter. What I mean by a wireless adapter is a USB device that connects through USB to your computer, and it allows you to communicate with wireless networks. Now, most computers and laptops come with a built-in wireless card. The only problem is, first of all, you can't access built-in wireless cards from a virtual machine. Also, even if you can, so even if you install Kali as a main machine, the built-in wireless cards are not good for hacking because we need a powerful adapter that supports monitor mode and packet injection, and we're going to go into what each of these mean. But basically, the built-in wireless adapter does not support these modes and can't be used for hacking. That's why I recommend powerful wireless adapters. They're listed in the course requirements, and I'm going to list them in the resources of this lecture, and you can connect them to Kali like I'm going to show you right now. So I already have VirtualBox open, and you just want to click the machine that you want to connect the adapter to. We're going to go to its settings. We're going to go to ports. We're going to go to USB. And make sure that USB is enabled. And you want to pick the USB option that is used by your adapter. So it's either USB 1, 2, or 3. And for the adapter that I have, it uses USB 2. Then you want to come here to the plus sign and click on it. Now you'll see that I have a number of devices that I can attach to the Kali machine. Now I still haven't connected the adapter. So first of all, I'm just going to have a look on the available devices. Then I'm going to connect the adapter. And I'm going to list the devices again. I did that because we're assuming that I don't know the name of my adapter, because the name that you'll see here is the name of the chipset that's used inside the adapter. So it's not the brand name that you see on the adapter itself. So when I click on it now, you'll see that I have a new entry called Atheros, and this is actually my wireless adapter. It's an Alpha AWS 036NHA. So I'm going to click on it. That's it added here. I'm going to click on OK. And that's the adapter added to Kali. Now, before we can start Kali, we have to install VirtualBox extensions to allow VirtualBox to use this USB device. Now, the download link will be included in the resources. I have the page already opened in here. And you can see in here, we have a link for VirtualBox extension pack, and you can just click on this link to download it. Now, this will only work for VirtualBox 5.1.22. If you have a different version, so to get your version, you can just go to VirtualBox, About VirtualBox. If you're on Windows, you'll have to go to File, About VirtualBox, and you'll see that I'm on 5.0.20. So I'll have to come back here, and I don't have the latest version, so I'm going to have to go down to the VirtualBox older builds, go on 5.0, and look for 5.0.20 and download its extension pack. So if you have the latest version that's listed on the main page, then download it from there. If you have an older version, go to the old builds like I did, scroll down and download the one that is compatible with your version. Now once it's downloaded, you'll be able to find it in your downloads or to whatever location you downloaded it to. And then you can just double click it to install it. So this is the one that's compatible with my VirtualBox. I'm gonna double click it. And as you can see, for me, it's telling me that it's already installed. For you, it's just gonna give you an install button. For me, it's called reinstall. So I'm just gonna reinstall it just to show you how it's gonna go. And we'll need to scroll down and agree. Put your password. And that's it. The extension pack is installed. So I'm gonna hit enter. Now before starting my virtual machine, I'm gonna physically disconnect my wireless adapter. And then I'm gonna connect the adapter once Kali fully loads. Now I'm gonna start it. So I'm gonna put my username, which is root, and my password, which is TOOR. Okay, now Kali is fully loaded. I'm gonna go and physically connect my wireless adapter. And like I said, I usually do this just to avoid any conflicts. Now once the adapter is connected, you want to make sure that it's attached to Kali. And to do that, we're gonna go to the devices menu. So we're gonna go all the way to the top. We're gonna go to devices. We're gonna go on USB. And we're gonna make sure that this adapter right here is checked. Now sometimes it might not be checked for you, so click on it to check it. For me it's already checked, so I'm not gonna click it. And to confirm that the adapter is connected, we can just go on terminal right here and type ifconfig. This command lists all the interfaces that's connected to the machine, and as you can see now, it's showing an adapter called LAN 0, which is the wireless adapter. So if you have this in here, that means your adapter is connected. If you don't, then ask in the discussions and I'll help you through this. Some adapters are not compatible with Kali, so that could be the issue, or the issue could be something else. Also, now if we go here on the top right, you'll see that I have a Wi-Fi option, which I can use to connect to Wi-Fi networks. Now we don't need to do this because I showed you how to set up a NAT network, and Kali already has internet access through this NAT network. So we only need the wireless adapter to hack into other networks to crack their passwords. MAC address. Each network card, whether it's Wi-Fi card or wired card, it has a physical static address assigned by the card manufacturer called the MAC address. Media access control. This MAC address is actually written on your card and it's physical, so it never changes. For your card, for your specific card, for example, for your Wi-Fi card, it will never change. It will always be the same. The MAC address is used between devices to identify each other and to transfer packets in the right direction. This works by each packet has a source MAC and a destination MAC, and it travels from the source MAC to the destination MAC. Now, because the MAC address is static and it never changes, it can be used to trace you back and to identify your device. Also, since devices use MAC address to identify each other, so for example, you'll have some networks that only allow certain MAC addresses to connect to the network. They use a whitelist. Or they can use a blacklist and blacklist your MAC address so that you cannot connect to that network. So changing your MAC address can help you either connect to the network by changing your MAC address to one that's in a whitelist, or it could let you bypass blacklists. So as I said, it's physical and static, so the only way to change the MAC address is to change it in the RAM. So it will only be changed for this session. Once you restart your device, you have to change it again. So to do this, it's very simple. We're going to use a tool called MAC Changer. So let's see how we do that. So first of all, to get your Wi-Fi card name, just type in iwconfig and it will show all wireless cards you have. So here ETH0 has no wireless extensions, and same with LO. and we can see that LAN 0 is my wireless card. So I'm just gonna disable the wireless card. So if config LAN 0 down, that's to disable the wireless card. Now we're going to change the MAC address. We're gonna use a tool called MAC Changer. So always with these tools, it's always a good idea to look at the help. So if you just go on MAC Changer, help, we'll see all the options that we can use with this tool. So you can use help and version to show the version, and help, show to show your current MAC address, E, so that it doesn't change the vendor bytes, it doesn't change the manufacturer of the MAC address. So another is just to try a random vendor MAC of the same kind. A is just to set a random vendor here, the capital A. P will reset to the original permanent MAC address. So if you change your MAC address and you want to use the old one, you can use P. Or will just give you a random MAC address, and L will just print the non-vendors that you can use. And M, actually, it'll help you pick your own MAC address. So you can, if there is a whitelist, and I'll show you how you can see all connected devices. So if your target network, you can see there's, for example, 3 devices connected, and this network only allows these 3 devices connect. So you can just take one of those MAC addresses and change it and use it yourself, and then try to connect, and it'll allow you to connect. So let's see how we change the MAC address. We're going to use MAC Changer again, and I'm just going to use random to set up a random MAC address, and then we'll put the device name, which is LAN 0. So very simple, MAC Changer random LAN 0. You can use the M to specify your own MAC address if you want. So I'm going to hit enter, and as you can see, my original one was this, and it's been changed to 98A4B095CAA3. Okay, so now our wireless card is ready and we've changed its MAC address. Now we need to enable it again because we disabled it by typing ifconfig LAN 0 down. So we'll do the opposite. We're going to do ifconfig LAN 0 up. And that's it. The card is enabled and its MAC address has been changed. Let's just have a look on it. If you type in ifconfig LAN 0, now we can see the new MAC address showing up in here. Now we know that the MAC address is used to make sure that the packet goes into the right direction. So each packet has a source MAC and a destination MAC, and it flows from the source MAC to the destination MAC, from the device that has the source MAC to the device that has the destination MAC. This is how wireless cards work in the default mode. So if I come in now to my Kali machine and I do iwconfig, you'll see that I have my wireless card right here called LAN 0, and you can see that the default mode is called managed mode. So basically in this mode, my wireless device will only receive packets, or will only try to capture packets that have my device's MAC address as the destination MAC. So it will only capture packets that are actually directed to my computer. What we want to do though, we want to be able to capture any packet that's around us, any packet that is within our range. So to do that, we're going to use a mode called monitor mode. This tells the wireless card is, I want you to capture everything around you. Even if the destination MAC is not your MAC, I want you to capture it. So basically we'll be able to capture all the packets within our range, even if the packet isn't directed to our device. There is more than one method to enable monitor mode. We're going to talk about 3 methods. We're going to start with the basic method in this lecture, and then I'm going to show you 2 more methods. The reason why I'm going to show you more than one method is sometimes monitor mode will be enabled, but when you actually come in to run an attack, the attack will not work. So in the future, if I run some attack and you see that you're getting different results, then just come back and try to enable mode in a different way. So we're going to talk about the first method now, and we're going to use airmon-ng to do it. So the first thing, let's just run the command on its own. So we're just going to type in airmon-ng. And you can see it lists the wireless cards available. And you can see that I have a wireless card called LAN 0. So I'm going to start monitor mode on this interface. And the command is going to be airmon-ng start LAN 0. So it's very simple. AirmonNG is the name of the program, start to start monitor mode, and LAN0 is the wireless card name, so it's the interface. I'm gonna hit enter. And as you can see now, it's telling me that monitor mode is enabled on Mon0. So now whenever I want to use monitor mode, I'm gonna specify Mon0 as the interface, and you'll see that in the future lectures. So for you, maybe you'll probably not get the same name. So for you, it'll probably be called LAN0 Mon or something else. It doesn't matter. Just make sure you use the name which monitor mode is enabled on in the future instead of Mon0 for me. So if I do iwconfig Mon0, you'll see that the mode now is monitor mode instead of managed, and that means that we can use this card now to capture any packet within our range, even if the packet is not directed to our device, even if it doesn't have the MAC address of our device as the destination MAC. Now I'd like to note a few things. First of all, when you enable monitor mode, the card will lose its connection. So if it was connected to a wireless network, it will actually get disconnected. This is normal because, as I said, the card will not be in managed mode and it will be capturing all the packets that's available to it instead of only capturing the packets that are directed to it. Also, it doesn't really matter because when we enable monitor mode, we'd want to actually hack into a different network or capture packets from networks that we don't have their password. So it's completely normal to lose your internet connection when you're in monitor mode. The next thing is, make sure that you use the name that monitor mode gets enabled on. As I said, for me it was Mon0. For you it could be called something else. So just make sure you actually use the name that AirmonNG tell you monitor mode got enabled on. As I said, it will probably be called LAN0 Mon or something else. The third note is, if you enabled monitor mode and in the future you ran an attack and you got different results than me, you got unexpected results, then just come back and try one of the other methods that I'm going to explain in the next lectures. Now, if you want to stop monitor mode, you can just do AirmonNG, stop, and then you put the wireless card name which is in monitor mode. Again, for me it's Mon0, for you it could be something else. And that's it. Now monitor mode is disabled and we can use LAN0 in managed mode to connect to networks and use it normally the same way that you usually use it. With the latest update of AircrackNG, AirmonNG stopped working for some of wireless cards. So it will work for some cards, but for others it will not work. It will actually say that it enabled monitor mode on LAN0 Mon. So instead of just Mon0, it's going to start calling them LAN0 Mon. And when you try to use this card, sometimes it's not going to work in monitor mode, even though your card supports monitor mode. So for now, I actually, with Kali 2 and with the new update, I recommend using a different method of enabling monitor mode. Now this method is actually the manual method of enabling monitor mode. So my wireless card is actually LAN0. So let's just have a look on it. So it's iwconfig LAN0. This is my wireless card, and as you can see now it's in managed mode. So what I'm gonna do is I'm gonna enable it using the manual method. So I'm gonna do ifconfig LAN0 down, same way that we did in the previous method, and now the card is disabled. Now the next command is the command that's going to enable monitor mode on the card. So it's just gonna be iwconfig LAN0, the name of the card, and then I'm gonna say mode monitor. So it's very simple. iwconfig is the command, LAN0 is the name of my wireless card, and I'm telling it to enable monitor mode on this card. So I'm going to hit enter, and that's done. Now, if you don't see any error messages, that means the commands are running successfully. So now I'm going to enable the card again. So I'm going to do ifconfig LAN0 up, and that's going to bring my card up. And if I do iwconfig LAN0, as you can see now, the card is in monitor mode. So in the next videos, I've actually used the old method of enabling monitor mode. So I've used AirmonNG, and I'll be using Mon0 as my card in monitor mode. But if you use this method, then LAN0 is the one that's going to be in monitor mode. So when I'm going to be running aerodumpng, I'm going to use LAN0 instead of Mon0 because monitor mode is enabled on LAN0 now. So as you can see now, the card works perfectly and monitor mode is enabled on it. Now you have the freedom of choosing any method you want, but this method will work on all cards, whereas the aircrack or the airmon-ng method, the method that's seen in the previous video, will only work on some cards. So we've seen two methods to enable monitor mode, and I'm going to explain a third method. Now all these methods achieve the same object, which is enabling monitor mode on your wireless card. The reason why I'm explaining so many methods is because which method work for you depend on your operating system, on your host operating system, and on the compatibility of the wireless card with both of these systems. For me, all three methods work fine. But some people, they have the first method work for them, for some people the second or the third. Now, in many cases, all of the methods will enable monitor mode on your card, but not all of the attacks will work. So sometimes maybe the injection will not work, or maybe creating a fake access point will fail. All of these things, we're going to explain them in the future, so don't worry about them. But basically, what the idea to take from here is, if you know your card supports injection, if it's an alpha card like the 036H or the 036NHA, or one of the known cards that support injection, if you Google the name of your card and injection isn't working for you, or the card isn't working well for you, then all you have to do is just unplug the card, plug it back in, and try another method of enabling monitor mode. So far you have two methods, and I'm going to explain a third method to enable monitor mode. Now, if any of the methods above work well for you, then stick with it. If they don't, then try this method to enable monitor mode. So I have my wireless card now connected. And as you can see here, it's called LAN 0 and it's my Atheros card. So what I'm going to do is I'm going to disable the card just as usual. So it's ifconfig LAN 0 down. And what I'm going to do now, I'm going to run a command to kill any service that might interfere with enabling monitor mode. So the command is airmon-ng check kill. And there's no G here. And as you can see, it killed two processes right now that Airmon think might interfere with enabling monitor mode. So what I'm going to do now is enable monitor mode the same way that we did in the first method. So it's going to be airmon-ng start LAN 0. Now, as you can see, monitor mode has been started on LAN 0 mon, which is a virtual wireless interface. So I'm going to do ifconfig. And as you can see, the mode is monitor. Now, as I said, all the three methods achieve the same goal. All of them enable monitor mode. And in the future, we're going to use this monitor mode in doing different attacks. So if the attack doesn't work for you, all you have to do is unplug your card, plug it back in, try another method of enabling monitor mode. And hopefully one of them will work well for you and you can carry out the attacks. Okay, so now we have our Wi-Fi card in monitor mode. We can sniff all the packets that are within our Wi-Fi range, even though they're not directed to our device, and even without connecting to any network, even without knowing the password or username to the network. So what tool we're going to use? We're going to use a tool called AeroDump-ng. It's part of the AirCrack suite. It's a packet sniffer, allows us to capture all the packets around us. We can run it against all the networks around us, so we'll collect any packet that are within our Wi-Fi range. Or we can run it against a certain AP or access point, so we'll only be collecting packets that are coming from a certain Wi-Fi network. We'll see how we run the program first. First, you need your Wi-Fi card in monitor mode. I have it now in monitor mode, and the name of the Wi-Fi card in monitor mode, it's WLAN 0. So we'll just clear this, and we will run AeroDump-ng and mon0. It's just as simple as that. Mon0 is the name of the Wi-Fi card that has monitor mode enabled on it. And now you can see it's starting to list all the networks around us. Another use of AeroDump-ng is to identify all the networks around us and to identify all the connected devices to these networks. So I'm just gonna Control C now to stop sniffing, and we'll just have a quick look now. All the packets that we sniffed now, we didn't save them anywhere, so there was really no point of analyzing the packets, because we just ran it against all the access points around us to see what networks are around us and what they and gather information about these networks. So you can see like there is quite a good bit of networks around me. The BSS ID is the MAC address for the access point. So each as we said, each network device has a MAC address, and it's here written under the BSS ID column. The PWR is the power. So it's how far is the access point from our Wi-Fi card. You can see the test IP. This is the AP. This is the test router that we will be running a few attacks against. It's here in my room, so it's very close to me. It's -34. You can see as you go down, the networks are further and further away from me. So the closest the network, the easier for you to get to sniff the packets, because obviously you're closer and the packets can be collected easier. Also, all the attacks that we're going to explain in the future, the closer the network to you, the more effective the attack, and the quicker you will gain your access or achieve your goal. Beacons is the signals that the AP send. So each access point send a certain type of packets to tell all the clients around it that I exist and I'm there. So even if the network was hidden, it will still send these beacons to tell everyone around that network is, I'm here, I'm an AP, I have my BSS ID to be this, and I'm running on this information. So this is the number of beacons that each access point is sending. The data is the number of useful packets that we have sniffed. We'll talk about this later when we start talking about decrypting web encryption. So we'll just leave this for now. S is the number of data packets that we have collected in the past 10 seconds. So as you can see, we have 0 here, so 0 data packets in the past 10 seconds. Channel is the number of channel that the access point is broadcasting on. So each access point broadcasts on a certain channel. This is used so that there is no interference between access points that are beside each other. So say for example, I have an access point here, and like 5 meters from me there is another access point. If both of them are running on the same channel, there will be interference between those two access points, and the signal between them will be shorter. So the range of those access points will be shorter. So we use different channels so that there is no interference between the packets that are sent in the air. MB is the maximum speed supported by this access point, so it can go up to 54. Ink is the encryption that's used in that access point. So we see the encryption here is web, here is WPA2, here is web again, we have WPA here, and if it's an open network you'll see OPN here in the encryption. Cipher is the cipher that's used to decrypt the packets. So for web it's web, but for WPA2 it can be CCMP, it could be TKIP. We'll talk about these later when we get into WPA cracking. Auth is the type of authentication that's required for this access point. So we have PSK, pre-shared key here. We have MGT for this one, and we'll talk about this later as well when we go to WPA cracking. In the previous video, we saw how we can use AeroDump-ng to see all the networks that are within our Wi-Fi range and collect information about these networks, such as the BSS ID, the channel, the distance between us and that access point, the encryption that it uses, and so on. Now after we do that, we'll see a certain network that we want to target, or a number of networks that we want to target. So once we have our target, it's more useful to run AeroDump-ng on that network only, instead of running it on all the networks around us. So in this video we'll see how we can do that. So I have my output here from just running aerodump ng-10 on all networks around me, and I'm going to target this network. So that's my home network, the UPC62. I'm going to start sniffing on that network only instead of sniffing on all networks around me. To do this, we're going to use the same program, so it's aerodump ng, and then we're going to specify the channel. So I'm going to give the channel, and the channel here is number 2, as you can see here. And then I'm going to specify the BSS ID, which is the MAC address of the target network, and it's this. So we're going to copy paste it. And then I'm going to add a write option, and this tells aerodump ng to log all the packets that it captures into a file. And the file name is, I'm going to call it now, so let's call it test UPC. And then we put the name of our Wi-Fi card with monitor mode, and it's mon0. So aerodump ng, same as the program that we used before. Channel, we put the channel of the target access point, and BSS ID, we put the MAC address of the target point access point, and write, we put the file name that we want all the packets to be stored on. And then we have mon0, the name of our Wi-Fi card with monitor mode. So I'm going to hit enter. And as you can see, the only network that shows up is UPC62. We don't have any other networks with us. And we can now have a look on this section. In the previous video, we had too many networks here, so we only had one section in aerodump ng. This section was missing here, the second section. So the first section, as we saw in the previous video, contains all the access points that are within our Wi-Fi range. This section here. Now the second section contains all the clients that are associated with the access points here. So in here, this is not a network, this is a client, and it's connected to this network. We know that because we see the BSS ID here. That's the MAC address of the network that this client is connected to. So the MAC address here is the same as the MAC address here. So that means this client is connected to this network. Now the station is the MAC address of the client. So this is the MAC address of the device that is connected to the network. Power is the distance between us and this device. Rate is the maximum speed that this device is running on. Lost is the number of packets that we lost, we couldn't capture from the target device. And frames is the number of useful packets that we collected from that device. We'll talk more about frames and data, as I said, when we start talking about web cracking. So just want to show you now the two main parts again. So the first main part is the access points that are within our Wi-Fi range. The second main part of aerodump is the clients that are associated with these access points. We have the MAC address of the access point here and the MAC address of the actual client in here. Now I'm going to Control-C. So now all the data has been logged into a file called test UPC. I'm going to use ls, which is a command to list files in Linux, and just list the files that aerodump created. So it's going to add a star after it. And we see aerodump automatically created four file formats. So in our command, we only specified the file name as test UPC. You can see that aerodump automatically added a 01 to the file name. It adds this just in case there is another file that has the same name. And then we have 4 different file formats: the cap, CSV, Kismet, and Kismet XML. Let's go have a look on the files here in my home directory. So it should be called test. Yeah, that's it. So that's the files here, and they're in the home directory because my terminal is working in the home directory. If we go pwd, we see we're in the root directory. Okay, now we can, after we sniff those packets, we can use a program such as Wireshark to analyze these packets and see what information we gathered. The problem is, in this specific network, it's using WPA encryption, so all the packets are encrypted, and we won't be able to decrypt them unless we have the key. So we're going to talk about how we crack the key in section 2 of this course. For now, let's just and we're going to talk about how we use Wireshark in section 3 of this course. So I'm just going to run Wireshark just to give you a quick look on how the packets show up. So they're not going to be useful. They're all going to be encrypted, so they won't really be any use to us. So if I'm going to go on the open file and test, yeah, that's the file name, and I opened it, and we see here we can get some information. So we can see, for example, here the source device is a Broadcom device, and it's going to it's just being broadcasted here. We can see here we have an Apple device communicating with the Broadcom. That's as much as you'll get. You'll get MAC addresses, you'll get maybe devices manufacturers, very simple information. All this because the network is encrypted. We're going to talk about how we can decrypt it and how we can get very sensitive information after we connect to the network. If it's an open network, you can connect to it straight away and jump to part 3, where we're going to talk about these powerful attacks. For now, I just wanted to give you a quick look on how the packets look when the network is encrypted. Don't be scared of Wireshark. We're going to talk about it again in the 3rd section. We're going to explain everything about it. So for now, I just wanted to show you a quick look on what the packets look like. The authentication attacks. So we're still in our 1st section of the course, which means all the attacks that we're going to talk about are attacks that we can launch on any network that is within our Wi-Fi range, even if the network has encryption, even if it uses a key, and even if we don't have that key. So we don't have to connect to any network to launch these attacks. The deauthentication attack is very useful. It allows us to disconnect any device from any network that is within our Wi-Fi range. To do this, we're going to spoof our MAC address to the target client MAC address. So the target client is the client that we want to disconnect. We're going to pretend to be him, and we're going to send a deauthentication packet to the router. So we're going to tell the router, I want to disconnect from you. At the same time, we're going to spoof our MAC address to the access point MAC address, to the router's MAC address, and tell the target client, the client that we want to disconnect, we're going to tell him, you need to re-authenticate yourself. So when we do this, we're going to successfully disconnect the target client. So we're going to pretend to be the target client and tell the access point that we need to disconnect from you, we want to disconnect from you, and then we're going to pretend to be the access point and tell the client, you need to reconnect, if you need to re-authenticate yourself. When we do that, the connection is lost. We're going to use a tool called AirPlayNG to do it. So let's see how we can do that. First of all, we're going to need to run AeroDumpNG on the target network, because we want to see which clients are connected to it. So we want to see what devices are connected to this network. So our first command is going to be AeroDumpNG, and I'm not going to need the right option, so I'm just going to delete it here. So all I'm going to need is AeroDumpNG channel. We put the channel of the target network, and BSSID, the MAC address of the target network, and we hit enter, and now we're sniffing on my target network, which is UPC62. So my target device is going to be this device. This method would work on any device, whether it's a Linux, Windows, Mac, if it's a phone, Android, iOS, it doesn't matter. They all use the same method of transferring packets, so it's going to work on any Wi-Fi enabled device. Let's make sure we have connection here. I'm just going to go to google.com, make sure I'm connected to the internet. Okay, so we see now that Google is working perfectly. Let's go back here, and I'm gonna split the screen here. So we're gonna run AirPlayNG now to disassociate one of the devices from the network. We can run it to disassociate all devices, but I found when I do that, it doesn't really disassociate all of them because we have too many targets to disassociate. So I'm gonna choose one target, which is going to be this device, the device that we just saw. So it's going to be AirPlay NG, and then we're gonna deauthentication attack, and then we're gonna put the number of deauthentication packets that we're going to send. So I just put a very large number to keep the device disconnected. Then we're gonna put the target access point. So it's the MAC address of our target access point. This is it. And then we're gonna put the source or the client MAC address. That's the device that we want to disconnect, and it's this device here. So I put its MAC address there, and I'm just gonna put 10 my Wi-Fi card with monitor mode. So again, AirPlay NG, deauth, the number of packets, then we put the MAC address of the target AP, and then the MAC address of the device that we want to disconnect. I'm gonna hit enter, and AirPlay NG now send in the authentication packets. Let's go to the target device and see if we still have internet connection. And as you can see, we lost our connection, and it's now trying to reconnect. It's not going to be able to reconnect because we're still sending the authentication packets. So this device is successfully disconnected, and we can launch this attack on any network that we want without we don't need to know the username, we don't need to know the password or the key to that network. Creating a fake access point. A fake access point is basically an access point that just looks normal to any user, and it doesn't have encryption on it, so people can connect to it without having to enter a key. It's an open network, and it should have internet connection to attract people to use it. So why would we create a fake access point? Well, if we create a fake access point, we're going to attract a large number of people to connect to this network and access the internet. Once they do that, they're going to be doing login to usernames, you can logging in to their accounts and doing what they want to do on the internet. Because the access point doesn't use encryption, so we'll be able to sniff it very easily and sniff and capture all the information that they log. Creating an access point is simple. It just needs to be set up correctly so that the access point can function correctly. Now the first thing we're gonna need, two cards. So one card is gonna be connected to the internet. It doesn't matter what card is it. It could be a 3G card, it could be a wired card, it could be a wireless card. All we need is a card that is connected to the internet. And then we're gonna need a second card, and that card has to be a Wi-Fi card. So this second Wi-Fi card is gonna be used as the access point. It's gonna be used to broadcast the signal of the access point. So this is our hacker device. We're gonna need two cards connected to our device. One card that is connected to the internet, and the other card is gonna act as an access point. It's gonna broadcast to tell all the devices around it that I'm an access point and you can connect to me and access the internet. So how are we gonna do this, or how it's gonna work? Say for example, client number 1 wants to access google.com. So it's gonna ask our Wi-Fi card to get that, because our Wi-Fi card is pretending to be the access point. Now the Wi-Fi card doesn't have internet connection, so we're gonna have to set it up in a way that once it gets a request, it goes and it talks to the second card that is connected to the internet. Now the second card is gonna go bring the request, forward it back through our device to the Wi-Fi card and back to client number 1. Let's do this again. So we have two cards, one of them connected to the internet. Let's say it's a wired card, that's what I'm going to use in my example. and the second one is a Wi-Fi card that's going to act as the access point, and it's going to broadcast the signal. So devices are going to connect to this device, to the Wi-Fi card. They're going to ask for google.com. The Wi-Fi card we're going to set up our device in a way that once it gets a request, it goes and it asks the wired card that has internet connection. The wired card is going to bring google.com, and it will bring it back to the Wi-Fi card. The Wi-Fi card will forward the packets back to client number 1. That's the theory part of how a fake access point is going to work. In the next video, we're going to do it in a practical way. We'll see the commands that we're going to need to use, and it's going to become more clear once you actually do it and once I explain all the commands to you. Okay, now we're going to talk about a tool called Mana Toolkit. Mana Toolkit is a tool that allows us to create fake access points. The tool is very easy to use, and it automatically creates the fake access point for us instead of us manually typing the commands to create the access point. The tool also has a few scripts that allow us to run a number of other tools to allow us to sniff the traffic that happens in this fake access point, bypass HTTPS, and even attempt to bypass HSTS. So the tool comes in with 3 main scripts. The first one is start no upstream. Basically, this script will create a fake access point, but this access point will not have internet connection. So when someone connects to this fake access point, they will not be able to connect to the internet. The other one, the start not simple, is my favorite one, which basically creates an access point, a fake access point with internet connection. So when someone connects to this access point, they will be able to access the internet, and all the packets will be flowing through our device because we are the router, or we are the access point. So we'll be able to analyze these packets, capture them, and read them. The third one is the start not full, will basically create an access point with internet connection, and it will also automatically start sniffing, so recording the packets that are flowing through this fake access point, and it will attempt to bypass HTTPS and HSTS. Now, I'm not going to be using the third one because a lot of the time this actually fails. And in the third section of this course, where we're going to talk about the attacks that you can do after connecting to the network, we're going to learn how to bypass all these things and how to sniff packets, capture them, read them, and analyze them. So for today's lesson, we're only going to use this start not simple, where we're going to create an access point with internet connection. And in the future, we're going to see how we can actually capture these packets and analyze them. So before I do anything, I just want to show you the settings for the Kali machine. So I just want to make sure that you use a NAT network as well. So if you go to settings to network, and make sure that you're using a NAT network. So this is exactly what I showed you in the previous lecture. Now make sure that you have Mana installed, and to install it, all you have to do is run apt-get install Mana Toolkit. Now I already have it installed, that's why it's telling me that it's already installed and it's the newest version. Now I'm going to clear this. Now right here, if we do ifconfig, you'll see that we have an interface called ETH0, and this interface is actually created used by VirtualBox by the NAT network. So it's a virtual interface that is connected to the NAT network, and it's supplying internet connection to this machine. So at the moment, I don't have a wireless card connected to this machine. And so if I do iwconfig, you'll see that I don't have a wireless card. And this machine has internet connection coming from the virtual network made by VirtualBox from ETH0. So if I try to ping google.com, you'll see I'm getting responses back from Google, which means that this particular machine have internet connection. Now you can go to Firefox and try to browse something, and Firefox will work. So I'm getting my internet connection from the virtual interface made by VirtualBox. You can get your internet connection from anywhere you want. So if you have 2 wireless cards, you can use 2 wireless cards. If you have an Ethernet cable, you can get it from the Ethernet cable. In this case, I'm getting it from ETH0, the interface with the IP address the one that is connected to the internet. Now, what I'm going to do is I'm going to connect my wireless card now to the Kali machine, and I'm going to go to the devices, USB, and pick my card. Now the card should show up when I run iwconfig. So the card is only used to broadcast the signal. It's not used to provide the internet connection. The internet connection is coming from the ETH0 from the virtual interface made by VirtualBox. So I'm going to do iwconfig. And as you can see now, I have a new card called LAN0. This card is in managed mode and it's not connected to any network. Okay, so what we're going to do now, we're going to set up Mana's configuration and start the fake access point. So the first thing we're going to do is modify the host APD Mana file, which is located in etc Mana Toolkit host apd mana.conf. And I used leafpad because this is the editor that I want to modify the file with. So leafpad is just the name of the program, and then we put the location where the file is located. So right here you can modify the settings of the fake access point that we're going to use. The most important thing is the interface that we're going to use to broadcast the signal. And for me, it was called LAN0. Remember when we run iwconfig, this is my wireless card. This is your wireless card that's going to broadcast the signal, and it's not connected to anything, and it's called LAN0. Now you can modify the MAC address or the name of the network. So the name of the network in my case is going to be called internet, and the channel is going to be set to 6. So I'm actually not going to modify anything. I just wanted to show it to you in case your wireless card was called something else other than LAN0. In most cases, it will be called LAN0. Now, the other file that we want to modify is the startnet simple, and this is the file that will launch the access point. So again, we're going to use leafpad. And in here, again, the first thing that you want to make sure that you set it correctly is the PHY. And this will be, again, your wireless card. So my wireless card was called LAN0. If yours was called something else, then put it in here. And the next thing, the upstream, this is very important as well. You should specify the card that has internet connection. This is the card that's supplying internet connection to the machine. For, in my case, it was called ETH0, the virtual card made by VirtualBox, and it was the one that had IP address. Again, everything is set up correctly here, so I'm not going to modify anything. I'm going to keep everything the same. I'm going to close it. And my last step is going to be running Mana, and it's going to be running the startnet simple. Instead of saying leafpad, we're going to say bash to execute this file. So our command is going to be bash user share mana toolkit run mana startnet simple.sh, and I'm going to hit enter. Now this happens sometimes. So the best thing to do, or the best thing that I noticed, is you literally just run it again and it should work the second time. Okay, so the access point is running now. And what I'm going to do, I'm going to go to my Windows machine and try to connect from it. Now, I'm going to use another wireless card for the Windows machine because the Windows machine is going to be a virtual machine as well. So I'm going to be using a second wireless card connected to the Windows machine to try and test this network. In your case, you can try to connect from your phone or from another laptop. Do not connect from your host machine because you will not have internet connection, because the host machine is the one providing the internet connection for everything. So you either test it from your phone, from a separate laptop, or you can test it from your virtual Windows machine, but make sure you use another wireless card with that machine. So we're going to go back to our Windows device and we're going to search for networks to connect to. And as you can see, we have an extra network now called internet. And as you can see that it has no password. So we're going to try to connect to this network. and we managed to successfully connect to this network. And I'm gonna go to my browser and see if I have internet connection. So I'm gonna go on bing.com. And as you can see that we actually have internet connection, and through this fake access point, and that all the packets now are flowing through this device, because this is the IP, this is like the router, so all the packets will be flowing through this device. Now we can actually use Wireshark or any other tool or TCP dump or T-Shark to capture the packets and analyze them. Now again, I'm not going to be talking about that right now, because we're going to explain it in details in section 3 of this course. So far, everything we've done, we didn't need to connect to any network to do it. The good thing about connecting to a network is you'll be able to launch more powerful attacks and get more accurate info when you connect to it. Now, if the network doesn't use encryption, if it's an open wireless network, then you can go ahead and connect to it, and then you're at section 3, you can sniff unencrypted data. If the network is a wired network, then you can connect to it using your wire, or you can try, after you connect to it with the wire, maybe you need to change your MAC address to something else so that you can connect. The main problem is if the network uses encryption, such as WEP, WPA, or WPA2. We've seen if we try to sniff the data will be encrypted. And if we want to decrypt it, then we need to know the key. And if we know the key, then we can just connect and the data will be unencrypted anyway. So that's the main purpose of this section of the course, is if your target network uses some sort of encryption, and you can't really do anything more now unless you decrypt or find the key so that you can decrypt the data and connect to the network. So we're going to talk about how to decrypt WEP, WPA, and WPA encryptions. The first encryption that we're going to talk about breaking it is going to be WEP encryption, because it's the oldest one, it's the easiest one to break, but we still need to learn how to break it because you will see networks that still use WEP encryption. WEP encryption uses an algorithm called RC4. Each packet is encrypted at the access point and then it's sent to the air. Once the client receives it, since the client has the key, it will be able to decrypt the packet and read the information inside it. So very simple. The IP encrypts the packet, send it, client receive it, the client has the key, so the client decrypts it. Same way when the client sends the packet, it encrypts it, and then send it in the air. The access point receive it, the access point has the key, so it will decrypt the packet. So each packet that is sent into the air has a unique key stream. WEP ensures that the key stream is unique by using a 24-bit initialization vector. So the initialization vector is a random number. It's sent into each packet, and it's sent into plain text. So this part, it's not encrypted. If you read the packet, you'll be able to read it in plain text. The problem with the IV, or the initialization vector, it's very short. 24 bits is not that long. So in a busy network, there'll be a very large number of packets sent into the air. This means the number of possibilities of random IVs will be exhausted, and we will have two packets that have the same initialization vector. So the initialization vector is a 24-bit random key. It's sent into the air in each packet, and it's sent into plain text as a plain text. In a busy network, we're going to have a very large number of packets. This means that the possibilities of unique IVs will be exhausted, and if we are sniffing all these packets, we will be able to collect two packets that have the same initialization vector. Once we have two packets that have the same initialization vector, AirCrackNG can be used. It'll use statistical attacks to determine the key stream, and after that it will be able to determine the WEP key. Okay, so from the above we know the more IVs or initialization vectors that we collect, the more likely that we'll successfully crack the WEP key. So our main goal now, when we try to crack web is to collect as much IVs as we can, because once we have a large number of IVs and we're gonna have two packets that use the same IV, then aircrack-ng is more likely to be able to determine the key stream and the web key for the target network. In the next video we'll do that. We'll see how that actually works, and it should be easier to understand. Okay, so from the previous video we know that to crack a web key, all we have to do is sniff packets from the target network and gather as much IVs as possible. Once we do that, aircrack-ng will be able to use statistical attacks to determine the key stream and then the web key. It does this because when we have a large number of IVs, as I said, the IV is only a 24-bit number, so it can be exhausted easily in a busy network. So once we have two packets that have the same IV, then we can decrypt the key stream and the web key. Now, when we have more than two packets, obviously the method is going to work better and our chances of breaking the key will be higher. So we're going to try to gather as much IVs as possible. Let's see the most basic case of cracking web key. First of all, I have my Wi-Fi card in monitor mode. So the first thing I'm going to try to do now is just see all the networks that are within my Wi-Fi range. And then I'm going to target one of those networks. So we're going to go aerodump ng 10, just very basic. And the second network that came up is the network that we're going to do our attacks on. So it's a test AP. So we're just going to launch aerodump against this network now. So we're going to put the BSS ID like we did before. Just launch an aerodump against this AP. And then I'm going to put the channel, number 2. And then I'm going to add a write to store all the packets that we capture into a file. And let's call it basic test AP. And that's it. So aerodump ng, BSS ID, MAC address, channel, and the file that we're gonna write stuff to, and our Wi-Fi card in monitor mode. Just launch an aerodump on a target network. Now, as you can see, this target network that I have here is quite a busy one. You can see the data and the frames it's going up quickly. Well, quick enough, not very quickly, but it was very quick at the start. It is a busy network, so we have a client here. This is the section where we see the clients. So this client is actually I have it actually playing video on YouTube, so that's why it's going up quick and it slows down, quick and slows down. So we're just trying to mimic active client here. So all we have to do now is just launch aircrack, which is part of the aircrack suite, against the file that aerodump has created for us. We can launch aircrack against it even if we didn't stop aerodump, and it's gonna keep reading the file and read the new packets that aerodump is capturing here. So we're just gonna go aircrack ng, and we put the file name. So the file name was So this file is still being created. It's still getting larger and larger because it's getting more packets. But we can run aircrack-ng with that file running, and then with aerodump running, and it's gonna keep getting updated, and it'll give us the password once it can crack it. So now aircrack is working, and aerodump is collecting the packets for us. As you can see, aircrack failed to determine the key within 5,000 AVs. So it's gonna, with 3,000 AVs, it's gonna wait until the AVs reach 5,000, and it's gonna try again. Now the number of AVs actually depends on the type of web. So there's two types of web encryption. There is 128 and there is a 46-bit. The only difference is the length of the key. So the 46-bit will require less number of IVs than the 128. Now the IVs, remember when we were talking about aircrack, we said data is the number of useful packets. What I meant with that is the number of packets that have a unique IV. or have a new IV. So the more packets we get with different IVs, the more our chances of cracking the web key. Now we're basically just gonna wait until aircrack can successfully crack the web key. Okay, perfect. I'm just gonna Control C error dump now. And as you can see here, aircrack successfully managed to get the key. So that's the web key for the target network. We were able to get it within 23,000 of data packets. That's because the target AP uses a 64-bit key. Let's see how we can use this key to connect to the network. So I'm just gonna copy it. I'm gonna go to Genie. And we're just gonna remove these dots and use the key like this. So now we can connect to the target network. And here we go. Let's see, test AP. And just gonna paste it here. Connect. And as you can see, our connection has been established. So we successfully recovered the key, the web key for our target network. So I can just go to confirm, ping Google, and ping works. So we are successfully connected to the target network. So in the previous video, we saw how easy it is to crack a web key in a busy network. So we had a busy network, we had a client that was watching videos all the time, and we saw how the data was increasing very quickly. Now the question is, or the problem that we're gonna face, is an access point that doesn't have any clients connected to it, or an access point that has a client connected to it, but he's not using the internet as heavy as we saw in the previous video, maybe just reading articles or just going on Facebook or whatever, but not using as much data as we saw last time. So let me just show you an example of that. I'm just going to run arrow dump against the target access point, the test AP, just to have a look on an idle access point. So we have test AP now, the same access point that we used before. The only difference is that I've disconnected the device that was connected. And you can see here in the second area, the clients area, that there is no clients connected. And you can see the data is 0 and didn't even go to 1. So that's going to be a problem that we're going to face. We won't be able to crack the key like this with 0 data. So what we can do is we can inject packets into the traffic. When we inject packets into the traffic, we can force the AP to create new packets with new IV in them. We capture that IV and we do that again. That's the basic case that what we're gonna do. But before we can inject packets into the air, we have to authenticate our device with the target access point. See, the way that access points work, they have a list of all the devices that are connected to them. And they ignore any packet that comes from a device that is not connected to them. So if a device that doesn't have the key tries to send a packet to your router will just ignore it. It won't even try to read it or see what's in there. So before we can inject packets to the router, we're gonna have to authenticate ourselves with the router. We're gonna use a method called fake authentication. And it's very simple. We're gonna have to do it before every time we try to inject. I'm gonna explain it now, and then in the future we're just gonna run the command straight away. So I have arrow dump already running now. Let's see how we can fake authenticate ourselves. Remember when I talked about arrow dump and we reached the auth, I said this is the type of authentication, and I said I'll come back for it later. So you see now the auth is, there's nothing here. Once we do the fake authentication, you're gonna see an OPN showing up here, which means we've successfully fake authenticated our device with the target access point. So to do this, we're going to use airplay-ng. We're going to use a fake auth attack. So we put the type of attack, and then we're going to put the type of the number of packets that we want to send. So I'm just going to do 0. Some people use a large number when they have when they're carrying attack that'll take like 5 or 10 minutes. But for me, I like to just use 0 and maybe do it later manually. So fake auth 0. We're going to use the option A, the target MAC address. So I'm just going to copy it from here and I'll paste it. That's done. We're going to use H to put our MAC address so that our MAC address gets authenticated with the target network. So to get our MAC address, we're just going to run the command ifconfig LAN 0, and that's my MAC address. So I'm just going to copy it. LAN 0 is the name of my Wi-Fi card. You can put Mon 0 because they're the same card, so they have the same MAC address. I'm gonna paste it here, and then I'll put the name of my Wi-Fi card, Mon 0. So airplay-ng, the type of attack that we're trying to do a fake authentication attack to authenticate our MAC address so that we can inject packets into the target network. We're gonna send 0, which means 1, do it once, and then A, we put the MAC address of the access point, and then H, we put the MAC address of the device that we want to do a fake authentication to, and that's my own wireless card. And then Mon 0, name of the Wi-Fi card, and then I'm gonna hit enter. And as you can see, it said an authentication request, and it was successful, and association is successful now. So, and you can see here in the auth, it became an open network, and our client, this is my attacking device, showed up as if it's a client connected to the network. We're actually not connected, but we are authenticated with the network, and we have associated with the network, so we can inject packets into this access point now, because it will receive any request that we send it now. It's not gonna ignore our requests. In the next videos, we're gonna see how we can inject packets into the air and how we're gonna make this data go up very, very quickly. The access point now accepts packets that we send to it because it's not gonna ignore us, because we've successfully associated ourselves with it using a fake authentication attack. Now we are ready to inject packets into the access point and make the number of data increase very quickly so that we can decrypt the web key. So the first method of packet injection that we're going to talk about is ARP request replay. In this method, we're going to wait for an ARP packet, we're going to capture this packet, and we're going to inject it into the traffic. When we do that, the access point is going to be forced to create a new packet with a new IV. We're going to capture this new packet, inject it back again into the traffic to force the access point to create another packet with another IV. We're going to keep doing this until the number of data is high enough to crack the web key. Let's see how we do this in Kali Linux. So first thing I'm going to do is just launch aerodump-ng. I'm just going to add a write to it, and let's call it this time ARP request reply test, and that's it running. And you can see that the target network has 0 data, so it has no clients associated with it, and there's no traffic going through, so it's not useful. We can't crack its key. First thing we're gonna do is we're gonna do a fake authentication now, and as you can see, the fake authentication was successful and the auth has changed to open. So we can start injecting packets into this network, and it'll accept our packets when we inject them. That's going to lead us to our third step, which is the ARP request reply step, where we will be injecting packets into the target network, forcing it to create new packets with new IVs. So the command is gonna be, just paste this now, very similar to the previous one, just instead of fake auth, we're gonna say ARP replay. I have an extra IR here, so ARP replay. Yep. Okay. And then instead of A, we're gonna have V for BSSID. So the first command here we did was just an association command, so that we can associate with the network and we can start injecting packets without being ignored. Here. The third one we're gonna do here is the command that we're gonna wait for an ARP packet, we're gonna capture it and then re-inject it in the air. Let me just associate myself again there, and I'm gonna launch this command. So in here in the third section, replay is just waiting for an ARP packet. Okay, as you can see, we've captured an ARP packet, and now it's injecting the ARP packet here. So it captured an ARP packet, it's injecting it in the traffic. The AP is creating another packet with a new IV. We're receiving it, injecting it again, and we're just doing this over and over again. You can see the number of data has already reached 9,000. I'm just gonna launch aircrack ng now. I think by the time I launch it, I'll be able to crack it. So I'm gonna aircrack ng, same command that we ran in the basic case. Let's just see lsstar.cap, and it'll show up for us. Yep, so that was it. So aircrack ng file name, and sure enough, here we see the web key, and we were able to crack it very easily. The number of data has reached 39,000 by now, so it's running up very, very quickly. We saw in previous videos how easy it is to crack WEP encrypted networks, even if there was no devices connected to the target network, and even if the target network was idle. We also explained a number of methods to inject packets into the traffic and cause the number of data to increase very rapidly, so that we can crack the WEP key in a very short period of time. Now in the next few tutorials, we're going to talk about WPA encryption. This encryption was designed after WEP, and it was designed to address all the issues that made WEP so easy to crack. The main issue with WEP was the short initialization vector, which is sent as plain text in each packet. The short initialization vector meant that the possibilities of having a unique IV in each packet can be exhausted in active networks. So when we were injecting packets or in natural active networks, we will have more than 2 packets that have the same IV. When this happens, aircrack ng can use statistical attacks to determine the key stream and then determine the WEP key. In WPA, however, each packet is encrypted using a unique temporary key. This means that the number of data packets that we collect is irrelevant. Even if we were able to collect 1 million packets, these packets are not useful because they do not contain any information that can help us crack the WPA key. Now I'm talking about WPA, but it's the WPA2 is the same. It works by the same method, and it can be cracked using the same methods. The only difference between WPA and WPA2 is that WPA2 uses an algorithm called CCMP for encryption. So cracking WPA or WPA2 encrypted networks, it's not simple, especially that all the packets that are sent into the air are not useful for us, as they do not contain any information that can help us determine the WPA key. Before we get into cracking WPA and WPA2, there is a feature called WPS. It allows users and clients to connect to the network by a push of a button. So on Windows 8, and if you look on some Wi-Fi printers, they have a WPS button. So if you press that WPS button and you go to your router and press the WPS button there as well, or go to the configuration page and press the WPS button, the client, the printer or your Windows device will connect to the network without having to enter the key. So the purpose of using WPS, it's a feature that allows clients to connect to the network easily without having to enter the WPA key manually. So it's just a feature in routers. This feature works and authenticates the client based using an 8-digit long PIN. So it doesn't use the actual WPA key, it uses an 8-digit PIN. This is only digits, and it's only 8 bits long, so there isn't too many possibilities for this. And if we use a brute force attack, we are guaranteed to guess this pin. If we successfully guess this pin, then we can use a tool called Reaver, which would calculate the WPA key from this pin. So we're going to brute force the pin, the 8-digit long pin. Because it's only 8 digits, we're guaranteed to be able to brute force it successfully. Once we do that, we can calculate the WPA key using Reaver. Again, this is only a feature in routers. This flaw is not in WPA or WPA2 encryption. The problem is in the WPS feature. So let's see how we do this first. To look for access points that have WPS enabled, we're going to use a tool called Wash. So I'm just going to put Wash I10. So we have our test AP showing up here. That's the AP that we're going to use to crack. So this is actually running on WPA now. It's not using WIP as we saw in the previous videos. I can confirm that for you here. I'm just going to use AeroDump. This step is not important. I'm just going to use it to show you that test AP is actually using WPA encryption. It's not WEP. So as you can see here, test is using WPA encryption. Let's just go back. So these are the access points that have WPS enabled, that have the WPS feature enabled. We can see the channel, the RSSI, which is the distance between us and the access point, the WPS version, and this WPS locked. Now, some routers, when you try to brute force the WPS pin, they lock after a few failed attempts. So if you try, for example, 4 wrong pins, they're gonna lock and not accept any pins for a certain amount of time. So if the WPS locked says yes here, then you can't actually use this attack now. So you need to wait for a little bit and come back to this access point. So we're gonna launch Reaver now. Reaver is going to brute force the WPS pin, and once it's able to find the WPS pin, it's going to work out the WPA key. Reaver supports pause and resume. So if you for example brute force 30% of the possibilities and cancel the attack, if you come back, you're gonna start again from 30,000. You're not gonna start from 0. So let's launch Reaver. We're gonna put B to choose the BSS ID or the MAC address of the target access point, and then C to choose the channel, which is 11, and then I and choose the Wi-Fi card with monitor mode, and that's 10. So very simple. Reaver, access point, BSS ID, channel, and then the Wi-Fi card with monitor mode. Gonna hit enter, and now Reaver associated with the target access point. It tried to determine the WPS pin. Now I have an easy pin, which is 12345670, and from that it was able to calculate my WPA key. So that's the WPA key, UAURWSXR, and that's just the name of the access point. So I can just come now and connect to my network. And if I put the key that we just found, I'm going to show the password, and it's UAURWSXR, connect. And as you can see, we connected successfully to the network. Now there's a few options that I'd like to show you for Reaver. I'm just going to go Reaver, help. And that's all the options that you can use with Reaver. So as I said, some routers would lock after a few failed attempts. Therefore, you can use some of these advanced options to get Reaver to work against these access points. For example, you can use the delay option and specify the amount of time in seconds that Reaver should wait between each brute force attempt or each pin attempt. You can also use the lock delay to tell Reaver to wait, for example, 60 seconds after if the access points gets locked, then wait for 60 seconds and then continue your brute force attempt. You can use the fail wait as well to set the time that Reaver should wait after 10 failed attempts. You can use the OR option to tell Reaver to sleep after a certain amount, to sleep for a certain amount of seconds after a certain number of tries. You can set up the timeout. You can play with these options, the delay options, and the timeout, the fail wait, and all that if the access point was locking or was ignoring some of your brute force attempts. So to crack a WPA key, the first thing we're gonna need is to capture the handshake. We're gonna capture the handshake using AeroDump-ng, the same way that we used to use it with WEP encrypted networks. So we're gonna run AeroDump. I'm just gonna run it on everything now to get the information about my target network. And this is my target. So it's AeroDump-ng, BSSID, same way we used to run it against WEP networks. At the end of the day, we're only capturing packets using AeroDump-ng, so it's doing the same job. So I'm gonna put the channel as well, and then I'm gonna write to a file, and then I'm gonna call the file test handshake, and then I'm gonna put the wireless card with monitor mode. So it's the same command we used to use when we were capturing packets for WEP networks. AeroDump-ng, BSSID, we put the target access point. Channel, we put the target channel. Write, we put the name of the file that we're gonna store stuff in. And 10 is our Wi-Fi card with monitor mode. Gonna hit enter. And here we go. So we have our network now. This is a WPA encrypted network. And we have here a client connected to this network. So to capture the handshake, again, we said the handshake packets get sent every time a device connects to the target access point. So now we can just sit down and wait for a device to connect to the network. Once the device connects to the network, we're gonna capture the handshake. Or we can use something that we learned in section 1, which is the deauthentication attack. In the deauthentication attack, we were able to disassociate or disconnect any device from any network that is within our Wi-Fi range. If we do that for a very short period of time, we can disassociate this device from the network for 1 second, and then the device is going to try to connect back to the network automatically, so that even the person who is using the target device is not going to notice that, but his device will actually get disconnected and reconnected so quick that he won't notice it, but we will be able to capture the handshake packets. So again, we said the handshake gets sent every time a device connects to the target network. So what we're going to do is we're going to do a deauthentication attack the same way we did it in section 1. We're going to disconnect this device from the network for a very short period of time. so that his system will reconnect him straight away without him noticing that, but we will be able to capture the handshake. So we're gonna just run a basic deauth attack using airplay-ng. We explained this in section 1. And in section 1 we put a very large number of packets when we were disconnecting our target. Now I'm only gonna put a small number only for the authentication packets. Then we're gonna put the MAC address of the target access point, and then I'm gonna put C to specify the client MAC address, the MAC address of the client that we want to disconnect, and then I'm gonna put my Wi-Fi card name, which is mon0. So airplay-ng deauth, the name of the attack, for the authentication packets to this access point and disconnect this device from it. Now I'm gonna hit enter, and just so I have it's deauth, I missed a U here. And as you can see, we captured the WPA handshake here. And my target device was this. By the way, it didn't even change in here. It didn't tell me I was disconnected, because it'll show a message when I get disconnected. So I didn't get any messages to be disconnected because I was disconnected for a very short period of time. And as a result, the target person didn't even notice it. And we were able to capture the handshake, as you can see here, WPA handshake from this device. Now we can use a word list and run it against this handshake to try and determine the main WPA key. Okay, now that we've captured the handshake, all we need to do to crack the WPA key is to create a word list. A word list is just a list of words that aircrack-ng is going to go through and try each one of these words against the handshake until it successfully determines the WPA key. So the better your word list is, the more your chances are of cracking the WPA key. If the password wasn't there in your word list file, you will not be able to determine the WPA key. Now I've attached a list of ready word lists that you can just download and use, or you can create your own word list using this video tutorial. We're going to use a tool called Crunch. It's basically just a script that you specify the characters that you want in the passwords, and it'll create all possible combinations of these passwords. So the format of the command of using Crunch is crunch minimum maximum. The minimum is the minimum number of characters of the password that you want to create. So you can say I want a minimum of 4, 5, 6, whatever you want. Maximum is the maximum number of characters in the passwords. Characters, you're going to specify the characters that are going to be used to create the passwords. So you can specify A, B, C, D, E, F, G, all the lower letters, and then you can write the capital letters. You can put numbers, you can put symbols. So here you'll specify the characters that you want. And then T is very useful if you know part of the password. It's a pattern. So for example, if you're trying to guess a password and you've seen someone type in this password, so you know, for example, it starts with an A and ends with a B. So you can use the pattern option and tell Crunch to create passwords that always start with A and end with B, and it'll put all possible combinations of the characters that you put in here. So for example, in this example, we have Crunch. We're going to create passwords of minimum of 6 characters and maximum of 8 characters. And the passwords are going to be combinations of the characters 1, 2, 3, 4, 5, 6. And these symbols is going to be stored in a file called word list. And the pattern is this password or that are going to be created, they're always going to start with an A and they're always going to end with B. So all the passwords that you're going to see in the file are going to always start with A and end with B, and they'll have all the possible combinations of the characters you specified here between the A and the B. So let's just run it here and create a sample word list. I'm gonna say crunch, and then we're gonna make a minimum of 6 and maximum of 6, or let's say minimum of 4, maximum of 6. And just so that it doesn't take a long time, I'm gonna make it short. I'm gonna put the characters. So I'm gonna just put 1, 2, 3 AB. I'm gonna store this in sample word list. So Crunch is gonna create a combination of passwords, minimum of 4 characters, maximum of 6 characters, and it's gonna create all possible combinations of 1, 2, 3 AB, and it's gonna store all that in a file called sample word list. Now we can read this file. We can just say cat sample word list, and we can see all the passwords that are stored in this file now. So that's all the passwords that Crunch created for us. So you can see it was 19,375 combinations possible from only 1, 2, 3 AB. Obviously, the bigger the password that you put, the more characters you put, the more passwords that you can make, and the more space they're gonna take. So let's just have a look on the pattern option. So we'll go crunch. Let's say a minimum of 5 and a maximum of 5. So all passwords, I want them to be 5 character long. And then I'll put the characters, which are 1, 2, 3 AB like before. And then I'm gonna add the T option, which is the pattern. And I'm gonna say I want a password start with an A and end with a B. And I want all possible combinations of my characters between the A and the B. And then we're gonna specify the output file, and let's call it pattern word list. And you can see here it's gonna create 125 passwords, and let's have a look on them. And as you can see here, it's always starting with an A and always ending with a B. So you can use Crunch now to create your word list, and in the next video we're gonna use the word list and the handshake file to determine the actual WPA key. Now that we've captured the handshake from our target access point and we have a word list ready to use, we can use aircrack-ng to crack or determine the key for the target access point. Aircrack-ng is gonna go through the word list file. It's going to combine each password with the name of our target access point to create a PMK. The PMK is created using a certain algorithm called the PBKDF2. So it's not like just combining the password and the ESS ID. It's encrypting them in a certain way. And then it's going to compare the PMK to the handshake. If the PMK was valid, then the password that was used is the password for the target access point. If it wasn't valid, then aircrack-ng is just going to try the next password. So again, aircrack-ng is going to go through the list. It's going to combine each password in the list with the name of the target access point to create a PMK. The PMK is compared with the handshake. If the PMK is valid, then that password is the password for the target access point. If it's not, then it's just going to try the next password. All this is going to be done using aircrack-ng. Let's see how we do it. So it's going to be aircrack-ng, the name of the file that contains the handshake, and that is test handshake01.cap, and then we'll put -w and the name of the word list. So I have it called WPA word list. So aircrack-ng, test the name of the file that contains the handshake, and then we have the name of the word list after the -w. I'm gonna hit enter, and now aircrack-ng is gonna go through the list. As you can see, it's trying all the passwords. It's gonna combine each password with the name of the target access point. to create a PMK and then compare the PMK to the handshake. If the PMK is valid, then the password that was used to create the PMK is the password for the target access point. If the PMK is not, then it's just going to try the next password. And as you can see, the key was found, and that's the same key that we were able to find when we attacked it using the WPS feature. So this was the basic way, using a word list, and it took 2 minutes and 16 seconds to crack the password. Now the speed depends on how quick your processor and if you have any processes running that's making your computer a bit slower. Okay, so through all the previous lectures, we've seen all the weaknesses that can be used by hackers in order to compromise WIP, WPA, and WPA2 encrypted networks. We've seen how they can use these weaknesses to crack the password and get the actual key to the network. We also seen that attackers are able to deauthenticate or disconnect any device from any network without the need to know the key to that network. And in the previous lecture, we've seen how we can modify the settings of our routers so that we can increase the encryption of our network, increase the security of our networks so that hackers can't use the attacks and get the password. Now, in order to apply the settings that we talked about in the previous lecture, you need to be able to access the settings page for your router. Now, each router has a web page where you can modify the settings for the router, and it's usually at the IP of that router. So first of all, I'm going to check and get the IP of my computer or of my device, and I'm just going to do ifconfig lan 0. And as you can see, this is the IP of my computer. So I'm going to open my browser, and I'm going to navigate to 192.168.0, and the IP of my computer was 25. Usually the IP of the router is the first IP in the subnet, so this is the subnet at the moment. It's 192.168.0, and I'm just going to add number 1 because that's the first IP in the subnet, and that will take me to the router settings page. And as you can see, it's asking me to enter a username and a password. Now, routers come in with a pre-specified username and password. You can check what's the default username and password, and then I highly recommend you change them after that. So usually it's written in the manual. So check the manual, see what's the default username and password, and then you can log in. Now, in some cases, the attacker might be doing a deauthentication attack against you, so he might be preventing you from connecting to your network wirelessly. So what you can do is you can connect to your router using a cable, using an Ethernet cable, and when you do that, then the attacker cannot use a deauthentication attack to deauthenticate you or disconnect you. So you'll be able to access your router settings using the wire, and then you can modify your security settings and change the encryption, change the password, do all the things that I recommended in the previous lecture in order to increase the security so that the attacker will not be able to attack your network and get the key. Now, the settings of each router are different. They depend on the manufacturer and even the model of the router. But usually the settings, the way that you change the settings is the same. And like 90% of the cases, the router is always at the first IP of the subnet. So all you have to do is you get your IP using ifconfig command like we did here when we got it, and it was 192.168.0.25. That's the IP of my device. And then I changed the last 25 to number 1 to the first IP, and that is the IP of my router. Now, I'm going to navigate to the wireless settings. Now, as you can see, there's a lot of settings that you can change for your network, and we're concerned with the wireless settings at the moment. So, as you can see, my wireless is enabled. You can change the name of the network, you can change the channel, and the bandwidth and all that. So I'm going to go to the security, and as you can see now, I'm using WPA encryption with WPA or WPA2 authentication, and the encryption using AES and TKIP. And if I go on WPS, you can see that the WPS is disabled, as we said now. So basically, I'm not using web, so they cannot use any of the attacks that we spoke about that allow you to crack WEP encryption. I'm using WPA, which is much more secure, and I disabled WPS, so they cannot use Reaver to determine my WPS pin and then reverse engineer my password. The only way that the hacker can access or get my password is by obtaining the handshake first and then use a word list to find my password. Now my password is very random, even though it actually doesn't use numbers or digits, just letters, but it's very random, so there is a really small chance of someone being able to guess that password. Now there is another thing that I'd like to show you here is the access control, and using this you can add policies. So you can add an allow policy or a deny policy, and using that is based on the MAC address. You can specify MAC addresses that you want to allow to connect to your network. You can also specify MAC addresses that you can deny from your network. So for example, you can just, if you don't have many visitors coming to the house, or if you're in a company with a specified number of computers and you want to only to allow a number of computers to connect to that network, then you can just ask the people, get their MAC addresses, the people that you want to allow, and add them in an allow list. Now, even if someone has the actual key, the right key for your network, and they don't exist in the whitelist or in the allow list, they will not be able to access the network. You can also add a deny list, which is if you want to deny a certain computer or a certain person that you think are suspicious, you can just add their MAC address in the deny list and they will not be able to connect to your network. So this is about it. As I said, the settings page usually look different. The names might be called different names, as in the names for each of these tabs. But usually the main thing is you should be able to access the router settings using the subnet IP and adding number 1, which is the first IP at the end. And if you're being attacked, if you can't connect to your network at all, then just use a cable and modify the settings like we discussed in the previous lectures. Everything we've done so far was without connecting to a network. In this section, we're going to be talking about post-connection attacks, so attacks that you can do after connecting to a network. Now, it doesn't matter if this network was a wireless or a wired network, and it doesn't matter how you managed to connect to it. We're going to forget all about what we did so far, and we're just going to assume that you have connection to the network. So you could have just connected physically using a wire to the router or to the server and you gained your access. You could have managed to crack the key if it was a WEP or WPA key, and then now you have access to the network. Or you could have the network maybe wasn't using any encryption and it was a wireless network and you just connected to it. So it doesn't matter how you gained your connection. If you are in a network, then you can launch all of the attacks that we're going to talk about in this section. One thing I'd like to note first though is if you're in a wireless network, then in all of the previous attacks we were setting our wireless card in monitor mode so we can capture any packet that goes in the air. In this section we're going to be using our wireless cards in managed mode because we only want to capture packets that are directed to us because we have access to the network, so we don't really need to capture everything. Another thing is if you're testing in your lab and you want to test these attacks without using a number of wireless cards. So in my case, I'm actually going to be connecting to my network using a Wi-Fi card from the Kali machine. Otherwise, what you can do is you can, on your settings here in the virtual box, make sure that your Kali machine, if you go on the settings and go on the network, make sure that it's using NAT network and make sure it's on the same subdomain as the other devices. So that's the Kali one, and then the Windows machine, we're going to be trying to hack into it or launch attacks against it. If you go on the network, you'll see that it's connected to a NAT network and it's the same network. You can do this and use ETH0 in your attacks from the Kali machine. It's going to be a virtual interface, but it's just going to work just as a normal interface. Or alternatively, you can use your Alpha card, just connect from your Kali, connect to your target network, and then you'll be able to test the security of any device that is in your network. So you can connect your virtual machine, your Windows virtual machine, to the same network, or you can just test any other device that you have. You can test it on your phone or an old laptop or anything else. The first thing we're going to talk about in section 3 is gathering information. Gathering information about the connected clients and the router is very important because it will help us know what their IP address is, their MAC address is, the operating system that they're running, the ports that they have open in their devices, and for example, for the router, we'd be able to know the manufacturer of the router, and then we'd be able to look for exploits and vulnerabilities that we can use against the router or against the clients if we're trying to hack them. In section 1, we saw how we can use AeroDump-ng to discover the connected clients. We saw in the second part of the AeroDump output, we saw how we can see the associated clients and we can see their MAC address. That was about it. That's everything we can get before we can connect to the target access point. Now, after connecting, we can gather much more detailed information about these devices. We're going to talk about 3 programs. Now, there is a lot of programs that does that. We're going to talk about 3 programs. We're going to start with the simplest and quickest one, and that is NetDiscover. Let's see how we can use NetDiscover. As I said, it's the quickest and the simplest, but it doesn't show very detailed information about the target clients. It will only show us their IP address, their MAC address, and sometimes the hardware manufacturer. So we're going to use it by typing NetDiscover. Then we're going to put I and specify our wireless device, which is WLAN 0. As you can see, I'm using LAN 0 instead of MON 0 because I'm using it in managed mode. I don't want to capture any packet that's in the air. I only want to capture packets that are directed to my device. And then we're going to put the range. You can put any range you want. If I look at my IP, and we can see my IP is 11. So this is the network that I'm in, 192.168.1. So I want to discover all the clients that are in this network. So we're going to try to see if there is a device in 192.168.1.1. Then we're going to try 12, 13, 14, 15, 16 up to 254. That's the end of the range. So to specify a whole range, you can write it like this. Over 24. So that means I want to 192.168.1, and then in here we're just going to increase up to 254, which is the end of the IP range in the network. So I'm going to hit enter. And as you can see, it's finished. That was very quick. As I said, it's the quickest way. And we can see we have 1, 2, 3, 4 devices connected to the network, and we have their MAC addresses here, and just very simple. Sometimes you can have the MAC vendor, but here it's not showing up. But that's about it. It was very quick, and it just shows simple information. Autoscan is another program that can be used to discover computers or clients connected to the same network. It's not as fast as NetDiscover, but it has a graphical interface, so it's easier to use, and it actually displays more detailed information about the discovered clients. You can download Autoscan from this link. So I'm just going to go to my Kali machine, and it's right here. You can download the Linux version from this link. The problem is the latest version, which is 1.5, actually has a bug, so it doesn't work very well. So what I'm gonna do is I'm gonna download an older version, which is 4.2. So I'm just gonna ignore this. I'm gonna click cancel, and I'm gonna go to files here. So I'm just gonna delete everything in there, and I'm gonna go on Autoscan, and I'm gonna go on 1.42. And I'm gonna download the Linux version. Now I'm actually gonna put a direct download link in the description, so you can just click on that in the resources of the lecture. So I'm just gonna save this, And that's it, it's downloaded. So if I go to my files and go to downloads, you'll see that we have the file downloaded right here. So I'm gonna extract that file by right click and click on extract here. And you can see that we have the installer right here. Now you should run this installer in the terminal, but before we do that, there is a library that we need to install that Autoscan uses. This library is only available to computers that have a 32-bit architecture, so to 32-bit processors. So we need to add that architecture first, then install the library. So the first command we're going to do is add the 32 compatibility to our 64-bit computer. If your computer was 32-bit, then you don't need to run this command. If it's 64, then you need to run this command. So you can run it anyway, there's no harm. So I'm just gonna run dpackage, add architecture, i386, hit enter. Now we need to update the sources, so I'm going to do apt-get update. Now I'm going to install the library that Autoscan needs, and it's called libc6. So we're going to do apt-get install libc6 i386. Now it's telling me, do I want to install it? I'm going to say yes. Now it's telling me, do I want to restart the services as configurations are made? I'm going to say yes. Okay, now it's all installed. We installed the library that Autoscan needs. Now all we need to do is just install Autoscan itself. Now as you remember, Autoscan was downloaded in the downloads folder in a folder called Autoscan Network. So we're going to navigate to the downloads. We do cd downloads. Then if we list the files, you'll see that we have the Autoscan installed directory. So we're going to open that doing cd Autoscan Network. Then if I list this, we'll see the installer itself written in green. To run that, we're going to do bash and then write the name of the installer. Hit enter. That's the newer version that you install with bash. So with this one, you actually just run it like so. You put / /, and then you put the name of the installer, which is Autoscan. Hit enter. And now it's asking me, telling me that this is going to install Autoscan. Do you want to go ahead with that? I'm going to say yes. Now it's telling me where do I want to install it, and I'm going to keep it as the default place, which is opt Autoscan. And now the program is fully installed. So if we go to the desktop, you'll see that we have a launcher here on the desktop. And also if you go on all the programs and look for Autoscan, you'll see that we have two files, the uninstaller and Autoscan itself. So I'm going to run Autoscan. And here we go. This is the program, and now we can use it to discover clients connected to the same network as us. So let's see how we use Autoscan. This wizard will actually help you start the scan and see the results. So we're just going to click on forward. And it's telling us to call the network something. We're just going to keep it as local network. I'm going to do forward. And again, it's still asking us where the network is. It's our local host, so I'm keeping it the same. Going to hit next. And now Autoscan is showing us the available interfaces. This is really important because depending on which interface you pick, you'll discover the devices connected to the same network that this interface is connected to. For example, right now I have two interfaces. I have ETH0 and LAN0. LAN0 is an actual wireless card connected to my real home network. So if I use this interface, I'll be able to discover all the devices that's connected to my Wi-Fi home network because LAN0 is connected to that network. I also have ETH0, which is the virtual interface created by VirtualBox, which is connected to the NAT network. So if I use ETH0, I'll be able to discover all the computers, all the virtual computers inside VirtualBox only. So I'm going to use LAN 0, which will allow me to discover all the computers around me, the real computers. I'm going to go forward, and then we're going to go forward one more time. And now the program is working, and as you can see, it's already discovering devices in my network. So give this some time. It's first of all, it's going to discover the IPs. Then it'll try to gather information about the open ports, the operating system, and the services used on these open ports. Now the scan is over, and as you can see now from the left, we can see all the devices in my network. Clicking on any device will show you more information here on the right. For example, I clicked on my router right now. Now it actually wasn't able to discover or know which operating system is used on that device, so it's asking me to add it manually so it knows in the future. I'm just gonna cancel this now. And you can see that it got me more information than NetDiscover. So first of all, you can see the IP, you can see the MAC address, and you can see the manufacturer of the wireless card right here. Now you can see it's also telling you that this is probably a gateway of the LAN, so it's probably not an actual computer, it's probably a router. Now right here you can see we have the open ports, and you can see that we have port 53 open, which is a DNS port. And you can also see that HTTP is open, which is a web server port. So basically you can try and put this IP, which is 192.168.0.1, and then you'll be able to access some sort of a website. And this is true because using that IP, you'll be able to access the website that allow you to configure the router. Now you can go ahead and try to access the other devices, see the services that you can discover, and see if it manages to discover the operating system on these devices. This is it really. As I said, it's easier to use and it shows us more information than NetDiscover, but it'll take longer time to actually scan the network and discover the information. In the next video, we'll have a look on ZenMap, which will show us more detailed information about the connected clients to our network. The third program that we're going to talk about to discover connected clients and gather information about them is Nmap. Nmap is a short for Network Mapper. It's a network discovery tool that can be used to gather information about just about any device. You can gather information about any client that is within your network. You can discover clients that's within your network. You can gather information about clients that are outside your network. You can gather information about clients just by knowing their IP. You can put the IP and then you can gather information. Now, Nmap is a huge tool. It has many uses. It can be used to bypass firewalls, all kinds of protection and security. So there is like books and courses that are specific for Nmap only. In this course, we're only going to have a quick look on Nmap to show you that it's very useful and to show you some of the basic Nmap commands to discover clients that are within our Wi-Fi that are connected to our network and discover the open ports in these clients. We're going to use ZenMap, which is the graphical user interface for Nmap. And let's see how we do that. So we're just going to type ZenMap. So in the target, you're going to put your IP address. If there is only one IP address that you want to gather information about, you can just put that address. Or you can put a range like we did with NetDiscover. So it's 192.168.1.1/24. And from here you can have profiles. You can put a custom command here if you want. If you know a custom command and you want to use it, you can put it here. Or you can use one of the ready profiles here. So we're going to have a look on those ready profiles. We're going to have a look on the ping scan first. This is a kind of quick scan, but it doesn't show too many information. It only shows the connected devices. As you can see, we have the connected devices here, and we have their IP addresses and their MAC address, and we also have the vendor. So in NetDiscover, we weren't able to see the manufacturer for the device, neither with AutoScan, but you can see here with Nmap we were able to know that the 192.168.1.10 is a Cisco device. Sorry, the 192.168.1.1, that's the router. It's a Cisco device, so it's a Cisco router. Now we can go ahead and look for exploits in this device. We also know that the 198.1.10 is a HTC device, so that's probably a phone. And since it's HTC, then it's probably running on Android. So now we're having more information. We can see that this device, the 12 device, is an Apple device. So again, it's either a phone, a tablet, or a Mac. And then we can see that this device is a Dell, number 22. And here, this device, I don't know who's this manufacturer. And we have another Dell device on this IP address. So again, its ping scan was very quick. We were able to know the manufacturer, the IP address, and the MAC address of the connected clients. The next scan we're going to have a look on is the quick scan. Now this is going to be slightly slower than the ping scan, but we will get more information than the ping scan. We're going to be able to identify the open ports in each device. And here we go. You can navigate in between the devices from here, from this panel. So we can see the main, the router has these open ports. So it has number 80 open and these ports are closed. We can see again the, remember in AutoScan we saw that one of the devices had 22 port open. Now we know that that's the Apple device, so we still don't know what's this device, whether it's an Apple computer or a tablet or a phone, but we know it's an Apple device with 22 port open, which is the SSH port. We can go on all the devices, and as you can see, we can see the open ports on them. That's the Dell device. It has 2 ports open. It has a web server running on 80, and it has some service running on this port. Now let's have a look on the Quick Scan Plus, which will take the Quick Scan one step further. It's going to be a bit slower again from the Quick Scan, but it will show us the programs that are running on the opened ports. So in the Quick Scan, we saw, for example, port 80 is open, but we didn't know what's running on port 80. Or we saw port 22 running, but we didn't know what's running. We know it's SSH, but we don't know what SSH server is running on that port. So again, you can see this is taking longer than the Quick Scan. Right, so that did take some time. It was slower than all the previous scans that we talked about, but we can see that it gathered much more information. We can see that we have 2 Linux devices connected here. So it got us the operating system of the devices connected. It also got us the version for the programs. So for example, we have the 192.168.1.12, the Apple device. We didn't know what Apple device it was. We were saying it could be a computer, it could be a laptop, it could be a phone. Now we know on 22 open port, on the 22 port. Last time we only knew it's open. Now we know it's running. The server that's running there is Open SSH 6.1. So we can go again and look for remote exploits, and we can hack that device right away. And when we go here on the device type, you can see it's a media device, it's a phone. So it is actually an iPad, it's not a phone, but iPhones and iPads, they're classified, they use nearly the same iOS version, so that's accurate enough. As you can see here, it's Apple iOS, so we know it's not a Mac, it's not a laptop, it's either an iPhone or an iPad, and it's running iOS 4, 5, or 6. Okay, now if we go on the other devices, so we have, this is our Linux device, and we saw in the Quick Scan we were able to identify 80 and this port open. We didn't know we knew HTTP running on this, obviously, but we didn't know what version of server that's running on this. Now we know it's Apache HTTP server 2.2.22, and it's a Ubuntu device, and that is correct. It's an OS Luna, which is a version of Ubuntu. So this is again very accurate. We can go ahead and look for exploits and vulnerabilities for this. And this port, we didn't even know what service it runs on. Now we know it's a UPnP server, and it's MediaTomp, the type of server or the program. It's MediaTomp UPnP server. And again, this is very accurate. This is actually the version of the program. So and it's telling us it's a Dell computer, and that is correct again. So we're getting very, very specific, accurate information about our targets. We can see here the Microsoft device, again the Windows device. It's running Microsoft HTTPPA, which is another UPnP server on this port. You can also browse by the services, so you can go on HTTP and it will show you the devices that have HTTP open, or you can go on SSH and you see the devices that have SSH open. So let me just show you an example. So if we go back to the hosts and we go to this device, to the output, let me show you here. So we know it's an Apple device. We know it's a phone or an iPad, and we know it has 22 open. So that's the SSH open, and that means the device has been jailbroken. Because without jailbreak, you can't install you can't install SSH server on the device. Now, when you jailbreak, in the jailbreak process, it installs a root user on the device, and the password for that root user is Alpine. Now, it's ALPINE. Most people don't even know that happens, and even the people that know, like myself, are too lazy to change it. So in many cases, if you find an iPhone or an iPad device with 22 open, you can pretty much just try to log into it straight away with SSH. So we'll do that here. We're gonna go SSH 192.168.1.12, and we're gonna go to root at this. Yes. It's gonna ask me the password. I'm gonna type in Alpine, ALPINE, and as you can see, I logged in as root. So this is just an example of how useful gathering information is. Even if this didn't work, you can go, as I said, you can go ahead and look for exploits for these programs, and you will manage to gain access to this network. So gathering information is a huge step in penetration testing. Nmap is a huge tool. You can carry out so many types of scans. You can experiment with these profiles here, and I highly recommend that you read more about Nmap and increase your knowledge about it, because you will need to use it in many cases, not only in Wi-Fi networks or in Wi-Fi penetration testing. Man-in-the-middle attacks. In the next few videos, we're going to talk about what's known as man-in-the-middle attacks. This is one of the most dangerous and effective attacks that you can carry out in a network. You can only do it once you connect to the network. It can be used to redirect the flow of packets from any client to our device. This means that any packet that is sent to or from the client, the target client, will have to go through our device. And since we know the password, since we know the key to the network, we will be able to read those packets, so they won't be encrypted, and we will be able to modify them, drop them, or just read them if they contain passwords or important information. This attack is so effective because it's very hard to protect against. We're going to talk about the ways to protect against it, but it's very hard to fully protect yourself against this attack. This is due to the way ARP protocol works. It was programmed in a way that it's very simple and it's very effective, but it's not secure enough. ARP has two main issues. two main security issues. The first one is that each ARP request or response is trusted. So whatever my device says to other devices that are in my network will be trusted. So I can just tell any device that's with me on my network that I am the router, and the device will trust me. It will not try to make sure that I am actually the router. It will not make any tests to ensure my identity. If I tell any device that I am the router, the device will believe me. Same way if I talk to the router, and if I tell the router that I am someone else on the network, the router will trust me and will start treating me as that device. So that's the first security issue. The second security issue is that clients can accept responses even if they didn't send a request. So for example, when a device connects to the network, the first thing it's gonna ask who is the router. And then the router will send a response saying I am the router. Now we can just send a response without the device asking for who is the router. We can just tell the device I am the router. And because the devices trust anyone, they will trust me and they will start sending me packets instead of sending the packets to the router. So let's have a deeper look on how this man-in-the-middle attack works. It's going to work using a technique called ARP poisoning or ARP spoofing. This is done by exploiting the two security issues that we talked about in the previous slide. That's a typical Wi-Fi network, and we can see that when the client requests something, it will send the request to the Wi-Fi, to the router, and then the router will get the request from the internet and come back with the responses to the client. Now all this is done using packets. So what we are going to do is we're going to send an ARP response to the client, so we can send responses without the client asking them. So the client didn't ask for anything, but we can still send it a response. We're gonna say that my IP is the router IP. So the router, for example, has 192.168.1.1. So we're gonna tell the client the device with this IP has my MAC address. So we're gonna tell the client that I am the router, basically. This will cause the client to, instead of sending the packets to the router, it will start sending the packets to us, because we told him the device with the router IP is me, has my MAC address. After that, we're gonna do the opposite to the router. So we're gonna tell the router that I am the client. We'll do this by telling the router that my IP is the client's IP, and that client has my MAC address. So the communication of packets will be done through the MAC address, and the Wi-Fi router will start sending any packet that's meant to go to the client will be sent to us instead. This will redirect the flow of packets through our device. So when the client wants to send a request, it will send the request to us. So for example, when it wants to open google.com, it will send that request to our device instead of sending it to the router. Now our device will go to the router, it will get google.com. The router will send the response to our device instead of the client, and then we will send the packet back. So this means that each packet that is sent to the client or from the client will have to go through us. Since it's going through us and we have the key, we can read these packets, we can modify them or just drop them. So that's the basic principle of man-in-the-middle and ARP poisoning. Basically, we're gonna tell the client that we are the router, and then we're gonna tell the router that we are the client. This will put us in the middle between the packet flow between the client and the router, and all the packets will start flowing through our device. Then we can read the packets, modify them or drop them. Now let's see how we can run an actual ARP poisoning attack and redirect the flow of packets and make it flow through our device. We're gonna talk about a tool called ARP Spoof, which is part of a suite called DSNF. DSNF is a tool that contains a number of programs that can be used to launch man-in-the-middle attacks. we're gonna talk about ARP spoof only, and we're gonna see how to use it to carry an ARP poisoning, which would redirect the flow of packets through our device. ARP spoof is an old tool, but it still works, and because it's so simple, it's been ported to Android, iOS, and other smaller operating systems. Therefore, and there's a lot of people that actually like to use it to do ARP poisoning. That's why we're gonna show how to use this tool. In the next video and all the videos after that, we're gonna use a tool called EtherCap. We'll see how we use it and how we do ARP poisoning in that tool. But for this video, I just want to show you how to use ARP spoof because it's gonna be used a lot, so you need to know how to use it. It's very simple anyway. So I'm connected now to the target network, and my wireless card is in managed mode, not in monitor mode, because we only want the packets that are directed to our device. So let's see how we use the tool. It's going to be ARP spoof, I to choose our Wi-Fi card, so it's LAN 0. Then we're going to put the target IP address. So my target is this Windows device. If we go IP config, we'll see its IP, and that's its IP. It's 192.168.169. So then we will put the IP address for the access point, which is 192.168.1.1. This will tell the access point that the client IP address has my MAC address. So basically it's gonna tell the access point that I am the target client. After this, we're gonna have to run ARP spoof again. So I'm just gonna copy it. Actually, just let me copy it properly. And instead of telling the access point that I am the target client, I'm gonna tell the client that I am the access point. So we're just gonna flip the IPs. So by running these two commands, we're gonna fool the access point and the client, and we're gonna let the packets flow through our device. Now let me just show you in the target, this is the target device again. I'm gonna show you the ARP table. So if I just go ARPA, it's going to show me this is the ARP table. So we can see that this is the IP address for the access point, and we can see its MAC address. It's stored in this ARP table. Now once we do the attack, you'll see that the MAC address here for the target access point is going to change, and it's going to be my attacker IP address, MAC address. So let's do it and see what happens. I'm gonna hit enter here, and I'm gonna hit enter here. Now we'll also need to do something called enabling IP forwarding. We do that so when the packets flow through our device, they don't get dropped, so that each packet that gets through our device gets actually forwarded to its destination. So when we get a packet from the router, it goes to the client, and when a packet is coming from the client, should go to the router without being dropped in our device. So we're gonna enable it using this command, and that's it enabled. Now let's just go to the target device and have a look on the ARP table, and as you can see, the MAC address here is different than the MAC address there. Even though they're both pointing to the access point, you can see that the access point now have a different MAC address, and this MAC address is the MAC address for the attacker device. Let me just confirm that to you. If config LAN 0, you'll see that this MAC address is the same one as the one that this device think that the access point has. So this device now thinks the attacker device is the access point, and every time it tries to access the internet, or every time it tries to communicate with the access point, it's going to send these requests to the attacker device instead of sending it to the actual access point. This will place our attacker device in the middle of the connection, and we will be able to read the packets and do fun stuff with it. We're gonna see how we do that in the next videos. So for now, we just need to know how to do a basic ARP poisoning. We're gonna need to do this on every time we try to do a man-in-the-middle attack. In this lecture and the next few lectures, we're going to talk about a tool called Man-in-the-Middle Framework. And as the name suggests, this tool allows you to run a number of man-in-the-middle attacks. So let's run the tool, see how we use it, and we're gonna do a basic ARP poisoning attack exactly like we did in the previous video. I'm also going to be using my Ethernet internal virtual cards instead of the Wi-Fi card. So you can actually run these attacks, as I said, against Wi-Fi or wired networks. And you can do it using your wireless card. You connect it to the network, to the target network, and then do the attack like we did with ARP spoof. Or you can do it the way that I'm going to do it now using your Ethernet virtual card. I'm going to do it that way because I want to keep this within the virtual environment and I don't want to affect the wireless network that I'm connected to. So I'm just going to show you the settings here. If we go on settings and if we go to my network settings, you'll see that my Kali machine is connected to a NAT network, and the network is called 10.20.14 NAT. And if we go to our Windows machine, you'll see that it's connected to the same network, 10.20.14 NAT. So I'm going to log into my Kali, and if I do ifconfig just to show you my interfaces, you'll see that I have my ETH0 is connected to the internal network at 10.20.14.203. So I'm actually just gonna go on the Windows machine and do an ARPA to show you the MAC addresses. And you can see that we have the gateway at 10.20.14.1 and the MAC address ends with 3500. So we're going to run the ARP poisoning attack and see if the MAC address changes and if we can become the man in the middle. So to use the tool, the name of the tool is man in the middle F. So we're going to put the command first. Then we're going to tell it to do ARP poisoning. Then we're going to give it the gateway, so the IP of the router. And then we're going to give it the IP of our target. And then I'm going to give it the interface. So the command is very simple. It's man in the middle F, the name of the tool. We're doing ARP spoofing. Then you give it the gateway, and I spelled that wrong. So the IP of the router, and then you give it the IP of your target, and then you give it the interface. If you don't specify a target, it'll default to the whole network, to the whole subnet. The interface here, as I said, I'm specifying my wired virtual interface, but you can specify your wireless card if it's connected to the network. So I'm going to hit enter. And the tool is running now. Let's go to the Windows machine, do an ARPA, and see if we manage to become in the middle of the connection. So I'm going to run ARPA again. And as you can see, the MAC address has changed to 47E9. And that is the same MAC address as the virtual interface that we have here. So it ends up with 47E9. So that means we're the man in the middle at the moment. And the tool automatically starts a sniffer for us. So instead of ARP spoof, which only places us in the middle, this tool actually starts a sniffer, which captures the data that is sent by the devices in our network. So I'm going to go to a website. Now, first, I'm going to go to a HTTP website and see how we can capture the username and a password. And then in future videos, we'll see how we can capture passwords from websites that use HTTPS. So I'm going to go to a website called Carzone. And then I'm going to go to the login page to log into my account. And then I'm just going to use a username and a password. So I'm going to put the name as Zaid. And then I'm going to put my password, and I'm going to put a false password, but we'll just see how we can capture this password. So I'm going to put 123456. Now if we go back to man in the middle left, you'll see that we have the username has been captured, which is zaid@icecurity.org, and the password has been captured, which is 123456. So basically, we are able to capture any username and any password that is entered by the target computers, by the computers which were ARP spoofing. You can also see all the URLs that the person have requested. So for example, you can see that they requested carzone.ie. You can also see the URLs that Carzone requested. So these are only URLs requested by the ads that's displayed on the website. Now, in the previous video, we've seen how we can sniff and capture anything sent over HTTP requests. Most famous websites use HTTPS instead of HTTP. This means that when we try to become the man in the middle, when the person goes to that website, the website will display a warning saying that the certificate of that website is invalid. That way, the person will be suspicious and probably won't log into that page. So what we're going to do, we're going to use a tool called SSL strip, which will downgrade any HTTPS request to HTTP. So whenever the target person tries to go to https.hotmail.com, for example, then they'll be redirected to HTTP of hotmail.com. Let me show you first. So I'm going to go to my browser on the target, and I'm going to try to go to hotmail.com. Now, as you can see here on the top, you'll see that the website uses HTTPS. So if I try to become the man in the middle now, this website will display a warning. So to bypass this, we're going to use a tool called SSL strip to downgrade any request to the HTTPS website and get it redirected to the HTTP version of this website. Once we go to the HTTP version, then the sniffing the data will be trivial, exactly like happened in the previous video. So you can use SSL strip manually, but luckily man in the middle framework starts it automatically for us. So I'm actually going to run exactly the same command that we seen in the previous video. I'm not going to change anything in it. And if you notice here, once we run this program, you'll see that it will actually tell us that SSL strip have been started and it's online. So I'm going to go back and I'm going to try to go to hotmail.com, and you'll see that instead of the HTTPS version that we're getting here, we're actually going to go to a HTTP version of hotmail.com. Now notice the top here. Notice that there is no HTTPS, so we're actually at the HTTP version of the website. You'll also notice that we didn't see any warnings, so it just looks like exactly a normal website looking exactly like hotmail.com. So I'm going to put in my email. And again, I'm going to use a false password. I'm just going to put 123456. And I'm going to sign in. Now, if we go to the Kali machine, you'll see that we managed to capture an email of zaid@hotmail.com. And we also managed to capture the password, which is 123456. Now, websites like Facebook and Google are actually using something called HSTS. And what that does, basically, the browser comes in with a hard-coded list of websites that have to be browsed as HTTPS. So even if we try to downgrade the HTTPS connection to HTTP, the browser will just refuse to show the website or just show a HTTPS version of it, because the browser, without connecting to anything, the browser itself has a list stored locally on the local computer saying that it shouldn't open Facebook, Gmail, and such websites as HTTP. So whatever way we try to do, then the website will just refuse to open it in HTTP. So I'm going to try to go to Facebook. And you'll see that I'm still going to the HTTPS version. Now, Man in the Middle framework actually has a HTTPS plugin, a HSTS plugin, which attempts to bypass this, but it only works against old browsers. So it used to use an old vulnerability, which is patched now in new browsers. So basically, with new browsers, Gmail and Facebook at the moment, there is no way of bypassing their HTTPS connection because they use HSTS, which basically means they come in with hard-coded lists in which the browser refuses to open these websites as HTTP. As soon as there is a way of bypassing HTTPS and HSTS, a practical way, then I'll update the course and add that way. So far, we've seen how we can capture passwords from any computer that is in our network. And we've seen how we can even bypass HTTPS to capture passwords from famous websites that try to use encryption. What if the target person never actually entered their password? What if they use the Remember Me feature, so when they go to their website, they already get logged into that website? That way, they never enter the password is never sent to the server, and therefore will never be able to capture the password because it's not even sent. So let's have a look at that. So I'm on my target computer, and if I go to Dailymotion, I've already logged in there and I clicked on the Remember Me feature. So if I go to that website, you'll see that I'll already be logged into my account without having to enter my password. So in this case, the users actually get authenticated based on their cookies. So the cookies are stored in the browser, and every time the person tries to go to the website, they will be authenticated to their website based on the cookies. So what we can do is we can sniff these cookies and inject them into our browser, and therefore we'll be able to log into the account without entering the password, exactly the same way that the target person is being authenticated to their account. So to do that, we're going to use a tool called Ferret, and Ferret doesn't come in installed with Kali. So to install it, you're going to have to run apt-get install Ferret sidejack. I already have it installed here, so I'm just going to show you how to do it. So Ferret apt-get the package manager, and we're telling it to install a package called Ferret sidejack. Once you hit enter, it will install it for you. Now I already have it installed, so it's telling me it's already installed. Once you have that, first of all, we're going to become the man in the middle using the same command that we've been using in the previous videos, using man in the middle framework. Now you can become the man in the middle any way you want using ARP spoof or any other tool. Once you're the man in the middle, we're going to use Ferret to capture the cookies. Now there is a Ferret plugin that comes in with man in the middle F, but I'm going to do it here just to show you how the whole process works together with another tool called Hamster. So I'm going to run Ferret, and running Ferret is very simple. All you have to do is just type in Ferret, and then you put your interface, which is ETH0 in my case. Again, if you're using your wireless card, then put the interface, the name of your wireless card. And Ferret is running now, and it's ready to capture cookies, and it's already capturing cookies. Now what we want to do, we're also going to start a graphical interface, a web GUI, that will allow us to navigate, to inject the cookies and navigate into our system's session. So to do that, we're going to use a tool called Hamster. And running Hamster is even simpler than Ferret, so all you have to do is just run Hamster. And we're ready to go. So I'm just going to go over what's happening right now. So on the top right here, we're becoming the man in the middle, so we're doing ARP poisoning. On the right here, we're capturing the cookies using a tool called Ferret, and all we did is Ferret I interface name, so very simple command. And on the left here, we started a web GUI, which will allow us to see the cookies and inject them into our browser. And we did that by typing Hamster, which is the name of the program. So everything is ready now. I'm going to go into my target and log into my account. So I'm just going to go, for example, I'm just going to pretend that I'm browsing the internet. So I'm going to go to bing.com, and then I'm going to look for Dailymotion. And just go into the website. And as you can see, again, I'm being authenticated automatically without having to enter anything as username or a password. Now let's come here, and as you can see, now we managed to capture the cookies here on the right. And I'm gonna copy this link that they gave us, that Ferret gave us, and I'm gonna go to my browser. Now I need to modify my proxy settings to use Hamster. So we're gonna go on the settings here. We're gonna go on the preferences, advanced, network, settings, and we're gonna set it to use a manual configuration, and we're gonna put the port to 123.4. So we're using 127.0.0.1, which is our local address, and the port is 1234. Click OK, and then we're gonna navigate to the URL given to us by Ferret. So it's 127.0.0.1.1234. We go there. Now I've already selected my adapter, but in your case, you're gonna need to go into adapters and enter ETH0. Click Submit Query, and we can see that here we have two targets, and my target is this one. That's my target IP. So I'm gonna click on it, and you can see here on the left we have all the URLs which contain cookies related to our target. So now obviously a lot of these are ads websites or ads URLs, and we can see here we have a URL for dailymotion.com. I'm going to open that in a new tab, and as you can see, I'm actually logged in as Zaid without having to enter my username or password. So I can go on my channel and do anything that the target person is able to do without using the username and the password. And this is all possible because we stole the cookies that the person actually used to authenticate themselves with the website. So we're actually logging in exactly the same way that the target person logs in to their account. In this lecture, we're going to learn what DNS spoofing is and how to perform it. DNS is basically a server that converts domain names, so www.google.com for example, to the IP address of the device where Google website is stored. And since we're the man in the middle, we can have a DNS server running on our computer and resolve DNS requests the way we want. So for example, whenever a person requests google.com, we can actually take them to another website because we're in the middle. So when they request it, we'll actually give them any other IP that we want, and then they'll see a completely different website than what they're expecting. So we can have a fake website running on our own web server and get requests, for example, from live.com to that website. We can have a website requesting the target person to download a backdoor. We can do anything we want, really, pretending to be any other website. So the possibilities are endless of what you can do with this attack. Let's go and see how we can do this. The first thing, I'm going to be redirecting people to my web server. So the web server is going to be running on my local Kali machine. You can redirect people to any web server anywhere you want, but in this video, we're redirecting them to our local web server. So to do that, we're going to start Apache web server. Comes in pre-installed with Kali. So all you have to do is service, Apache 2, start, and the web server has started. Now, if we go to my IP address, actually, let me show you the files. So the files for the web server are stored in var www.html. So I'm going to open my file manager, and I'm going to go to var www.html. And if we open this, this is our index. So this is the page that will be displayed to people who browse our web server. Now you can have a whole complete website installed in here, and it will be displayed whenever a person visits your web server. At the moment, I have a really simple page that just says a simple text just as a proof of concept. Okay, so if we go to my browser and browse to 10.20.14.203, which is my own IP address, my internal IP. If we go to it, you'll see that we can see the text here. So we're all good. Let's configure the DNS server that comes in with Man in the Middle framework. And to do that, we're going to use LeafPad, which is just a text editor. and then we're going to go to etc, man in the middle framework, maninthemiddle.conf. Then I'm going to scroll down to where the A records are. And the A records are basically the records that are responsible to transform domain names or translate domain names to IP addresses. So we're going to be targeting live.com, and using the star is a wildcard. So basically we're saying any subdomain to live.com should be redirected to 10.20.14.203, and that's my own IP address. So you can replace this with any IP address. For example, you can put an IP address of a remote website that you have hosted on any hosting company, or you can have it redirect into Google, for example, if you put Google's IP. Any IP you put here will redirect live.com to it. So I'm going to close that, and I'm going to run my command, and the command is very simple to the commands that we were running before in previous videos. The only difference is I'm going to add one extra option, which is DNS. So it's exactly the same commands: man in the middle framework, ARP spoof, gateway, target, interface, and then we added one extra option, which is DNS. I'm going to hit enter, and you'll see that DNS spoofing is enabled. So let's go to the target and try to go to live.com and see what happens. And as you can see, live.com, it actually uses HTTPS, and it has been redirected to our own website, saying simple text, obviously. But as I said, you can have this in here. You can install anything you want. You can ask them to download something, or you can have a fake page and steal stuff, steal credentials or whatever you're looking for. It can also be used to serve fake updates to the target person, for example, or backdoor downloads on the fly. There is so many uses to DNS spoofing. So this is just the basic case of how you can do DNS spoofing, and then you can use it and combine it with other attacks or with other ideas to achieve really powerful attacks. In this video, we're going to have an example of a simple plugin that comes in with man in the middle F. So I'm going to do man in the middle F help. And if you scroll through all this help, you'll see a lot of plugins that you can use to do various things on the target computer. So you can use the inject plugin to inject code into the web pages that the target person loads, and we'll have an example on that later. What I want to do now is just show you an example of a simple plugin, and then we'll do more in the future. So for example, you can see here we have a screenshot plugin. And basically what this plugin does is it takes screenshots of each of the pages that the person uses. So whenever the person uses a page, it takes a screenshot of that page. And you can set up the interval right here. So that's the amount of time in which the program should take a screenshot. So it defaults to 10 seconds. So it takes a screenshot every 10 seconds, but you can modify it using the interval option. So we're having a basic look on how you use the plugins. So the first thing you do is you put the plugin name, and then you put the option that you want to set. So we're going to use the same command that we always use, and then we're going to put the plugin name after it. So the plugin name for me is going to be screen. And if you want to change the interval, you can put it this way. So you put the interval, and then you put the interval for taking the screenshots. I'm going to keep it at 10 seconds, so I'm not going to do anything. I'm just going to delete that. And I'm going to hit enter. And now we should be good to go. So I'm going to go to the target computer and just browse the internet. So I'm going to go to bing.com and Google anything. You can go on images, whatever, doesn't really matter. So it's taking screenshots of everything now. Well, every 10 seconds it's taking a screenshot, and you can see that it's actually injecting the code in here every time. So I'm going to stop this, and then we're going to go and have a look on the screenshots that we captured. So the screenshots will be captured into the logs directory. So I'm going to go to files, and it's going to be in var logs and in man in the middle F. And you can see all the screenshots that we captured. Now, some of them have actually been captured before from other sessions. So you can see right here we have the one for the picture, the one when I googled the pictures right here. And I'm going to close that. So all the stuff that's going to be captured, all the images will be stored in this directory, and you can see them and get an idea of what the person is doing on their computer. Now there's other plugins that you can use. So you have the JS keylogger, which will basically inject a keylogger into the target page. But it's kind of useless because since you're the man in the middle, you can see the usernames and passwords anyway, or anything that gets sent on the target computer. But if that's what if for any reason you wanted to have some sort of a keylogger injected into the target computer or into the target website, then all you do is, again, same command that we always run, and just type in JS keylogger after it. And that's the keylogger injected. So again, if we go here and search for something else, or maybe we go and log in somewhere. So let's go and go to cardzone.ie. And I put my password as 123456. Logging in, going back. Now obviously this has been captured because we're the man in the middle anyway. Now if we go up, you can see that our JS keylogger, it's detecting that stuff are being entered into the field that is called email, user email, and we enter TETES, and then we put test at, and the final result was test@test.com. And then in the password we were putting 1, 1, 2, 1, 2, 3 up to, and then it was 1, 2, 3, 4, 5, 6. So again, if the target person is writing anything on any page, then you'll be able to capture it using this. But anyway, since you're the man in the middle, you can do that using Wireshark and analyze all the packets and see what the person is typing. This is another method of seeing it or of doing it. It's an example of how you could use the plugins that come in with man in the middle F. Now again, typing man in the middle F will give you all the options, all the plugins that you can use, and using them is very similar to what I've been doing. So you usually just put the option or the plugin name. And in this lecture, we're going to be talking about how to inject code into the browser, into the target computer. So since we're the man in the middle and since everything flows through our device, then when someone requests a page, we can actually insert any type of code that we want into that page. Browsers can run two types of code. They can run HTML code and they can run JavaScript code. HTML code is the code responsible for the way that the page looks. So it's the code for the buttons, for the text, for the images, all of that. So it can't really be used to do anything that will allow us to gain any access to the target computer. JavaScript, on the other hand, it's a programming language that can be used to do many things, and we'll see that in future videos. In this video, we'll see how we can inject JavaScript code into the target person, into their browser. You can use the same method to inject HTML, but JavaScript is more useful. That's why we're going to use our example to inject JavaScript. So let's first of all run man in the middle F with the help command, and we'll see what options do we have with the inject plugin. So I'm going to do man in the middle F. And if we scroll up, you'll see that we have the inject plugin. So we're going to be using the same command that we always use. The only difference is we're going to insert the inject plugin. And then we have different options for injection. So there's three main options. There is the file, so you can have your code stored into a file, and you can use JS file or HTML file to inject the code stored in that particular file that you specify. Or you can use, if your code is stored online and it has a URL, then you can use that URL or that link using the JS URL or the HTML URL options. Or you can actually supply the code itself through the command using the JS payload or the HTML payload. So we're going to be supplying the code through the command the first time, and then I'll show you using a file. So we're going to be using the inject payload, and then we're going to be doing JS payload. So I'm actually going to run the command here so we still have the help. So our command is going to be the same as always, man in the middle F. And then we're gonna add the option, the plugin, which is inject. And then we're gonna tell it that we want to specify the code through the command. So we're gonna use the JS payload. Then you can put the JavaScript code after this option. So I'm gonna put my JavaScript code, and I'm gonna use very simple code that will only display a message on the target computer. So our code is not gonna do anything bad. It's not gonna try to hack anything. All it's going to do is just display a message box on the target computer. And in future videos, we'll see how we can use that this option to do more powerful attacks. So basically my code is going to do an alert, which is a function in JavaScript, and the alert is just going to say test. So our command is the same. It's man in the middle, F, ARP spoof, our interface, the gateway, the target, and then we loaded the inject plugin, and we're telling it we're specifying the code through the command. And the code that we want to run is alert, test, and that's it. I'm going to hit enter. And now the tool is running. Let's go to the target computer, browse a normal web page, and see what happens. So I'm just going to go to bing.com. And as you can see, the page bing.com displays a message box, and that message box says test. So again, this is very simple code that doesn't really allow us to do anything on the target computer. But we can use it in future videos to do more powerful attacks. Again, you can actually Google JavaScript codes and see codes that will be useful for you. For example, there's JavaScript keyloggers, there's codes that can take screenshots of the target computer, and there's a lot of codes. You can redirect the target computer somewhere else, steal their cookies. You can do a lot of these powerful attacks. Another way to run this attack is used in the file. So if you are using one of these more complicated codes, it's going to be hard to write it through the command. So you'll be better off storing the code into a file and using the JS file option. So all you'll have to do is open your leafpad or get your code. So I'm actually just going to run leafpad, and I'm going to write the same code that we did there in a file. So I'm going to do an alert, and I'm just going to do test2 this time. And I'm going to store that in my root. That should be okay. And I'm just going to say, call it alert.js. And that's stored now. So again, if you're Googling or if you're using a more complicated code, you can have it all into this file and then inject it using the way I'm going to do it now. And then run the same command that we did, but the only difference, instead of using the JS payload, we're going to use a JS file, and we're going to specify the file, the full path to the file. So I stored it in root and alert.js. So if you downloaded a file of the internet that contains a keylogger, for example, or a file that will redirect the target computer to somewhere else, then again, same command, but make sure you put the JS file, and then you put the full path to where that file is stored. I'm going to hit enter, and man in the middle is working for me. I'm going to come back here, and let's browse for something. Let's say JavaScript. And as you can see, our code, the second code that we put, which was called test2, was executed on the target machine. Now again, these are really simple codes, just displaying a message box, but you can download or look for more complicated JavaScript codes, or just follow up in the future lectures and see how we can use this feature to carry out more powerful attacks. In this video, we're gonna cover how to use man-in-the-middle F against a real network. Man-in-the-middle F can be used against real networks exactly the same way that we were using it against virtual networks. The only difference is you want to make sure that you specify the right IPs, the right interface, and connect to the same network that the target person is connected to. I'd also like to go over a few points that might prevent man-in-the-middle F from working properly. So the first thing that I'm going to do now is just do ifconfig to show you my configuration. And as you can see, I only have ETH0 right here, and it's connected to my NAT network because I configured my Kali machine to use a NAT network right here. So first of all, the first thing that you want to do before you target a real network is make sure that that's the only network that Kali is connected to. So the first thing that I'm going to do is I'm going to disconnect myself from this network. This is very important, and it's actually the main thing that seems to be interfering with man in the Middle Earth. So the attack might work, but you will have DNS issues, or the target machine will experience very slow internet connection, or they'll lose their internet connection completely. So the first thing we're going to do is we're going to disconnect from this virtual network. So we're going to go to devices, we're going to go to network, and see the check right here? That means we're connected to the network because it connects the network adapter. So I'm going to click that, and that's going to disconnect me from the NAT network. So if I do ifconfig now, you'll see that ETH0 is not connected to anything right now. So I'm literally offline in the Kali machine. I can't even ping anything. As you can see, I can't even ping Google. The next thing that we need to do is connect to the same network that the target machine is connected to. And in this video right here, I'm going to be targeting this Mac machine. So it's a real computer, it's a real physical computer connected to a real physical Wi-Fi network. And the name of the network is UPC 0460916. So this is the network that I need to connect my Kali machine to so that I can attack this computer. As we mentioned before, you can't use the internal wireless card inside VirtualBox, inside virtual machines. So to connect to a Wi-Fi network, we're going to need to use an external wireless adapter. I'm going to connect my wireless adapter right now through a USB port. And then I'm going to go to devices, USB, and connect my wireless card. That's the name of it, Atheros. Now if I do ifconfig, you'll see that I have a new interface, and it's called LAN 0, and this is my wireless card. But as you can see now, this wireless card is not connected to any network. So to attack our Mac OS machine, as I said, we need to connect to the same network that it's connected to. And to do that, I'm going to go click on this arrow. I'm going to go to Wi-Fi. I'm going to go to select network. I'm going to connect to the same network that the Mac is connected to. And I'm going to put the password. Now that I'm connected, if I do ifconfig, you'll see that LAN 0 has an IP address. And notice that the first three parts of the IP address here are the same as the first three parts of the IP address in Mac OS. So if I do ifconfig here, note that the first three parts here are the same as the first three parts here. And that basically means that these two wireless cards are on the same subnet, on the same network. And now I can use LAN 0 to target this computer right here. So if we do ARPA here, notice the MAC address now. This is the right MAC address of the router. And when we run man in the Middle Earth, this should change to the attacker's MAC address. So let's run man in the Middle Earth exactly the same way that we used to do before. So we're going to do man in the Middle Earth. We're going to do ARP spoof. We're going to give it the interface. And this time we're targeting a real computer, we're targeting a real network, and LAN 0 is connected to that network. So we're going to use LAN 0 for the interface instead of ETH0. Then I'm going to set the gateway, and that's usually the first IP in the subnet. So it'll be 192.168.0.1. And then I'm going to specify my target, which is the Mac machine, and it had an IP of 192.168.0.19. So again, it's exactly the same command that we did before. The only difference is we're using different arguments. We're using LAN 0 because LAN 0 is the wireless card that's connected to the target network. We're using the gateway, which is the first IP of the same IP that we have. and then we're using the target, which is this Mac machine, and we've seen it to be 192.168.0.19. I'm gonna hit enter and come back here. Now, as you can see, the old MAC address of the router used to be this. Now, if we do ARPA, the MAC address should change to the Kali MAC address. But as you can see now, in this case, it still didn't change. And the reason for this is because we're actually targeting a physical computer in a physical network. So this could actually take up to 1.5 minutes for the changes to reflect. So just give it some time and then check the MAC address again. I'm also gonna go and browse to a website just so that I'll generate some traffic on my computer, on the target computer, so that it'll go ahead and update its ARP table. Now let's check again. And as you can see now, the MAC address changed to the MAC address of the attacker's one. And if we go here, you'll see that man in the middle life is sniffing data and it's capturing data that's sent by my Mac OS. Now let's go to Hotmail and log in. Now I'm going to put the username as test@hotmail.com. And I'm going to put the password as 123456. And right here, as you can see, we managed to get the email, which is test@hotmail.com, and the password, which is 123456. And again, this worked against a real computer that's connected to a real network. So the main thing to keep in mind is make sure that you're connected to the same network as the target person. If that person is connected to a Wi-Fi network, then make sure you're using an external wireless adapter and you're not using bridged, you're not using NAT, you're literally connecting through the network manager of Kali Linux. So you need to attach the wireless card and then connect from here to the target network. Also keep in mind that you should disconnect the Kali machine from the NAT network if it was connected to one by going to Devices, Network, and then uncheck this option right here. Because we want to make sure that the Kali machine is isolated. It's not connected to any network other than the target network. So right now, if I do ifconfig, you'll see that ETH0 does not have any IP addresses. The only device that has an IP address and that's connected is LAN 0. Once you're done with all of that, and if you wanted to go back to using your NAT network to target other virtual machines, or if you just wanted to get your internet connection through the host machine, so if you wanted to use the NAT network again, all you have to do is just go to Devices again, go to Network, and click on Connect Network Adapter. That'll again connect your ETH0 to the NAT network and it'll allow you to use it as you were using it before. So if I do ifconfig now, you'll see that ETH0 has an IP address and it's connected again to the NAT network. In this lecture, we're going to talk about a tool called Wireshark. Wireshark is a network protocol analyzer. It's not designed for hackers and it's not designed for hacking and spying on other people on the network. It's designed for network administrators so that they can see what's happening in their network and make sure that everything is working properly and that nobody's doing anything bad or doing anything suspicious on the network. The way that Wireshark works is it allows you to select an interface and then logs all the packets or all the traffic that flows through that interface. So you're selecting an interface. It could be a wireless card, it could be a wired card on your current computer, and then it'll start logging all the information that flow through that interface. It also has a really nice graphical interface that allow you to analyze this traffic. So it allows you to filter these packets based on the protocol using them, like HTTP, TCP, and all that. It also allows you to look for certain things. For example, if you're looking for cookies or if you're looking for posts or GET requests. And it also allows you to search through these packets. You can search through the information that's stored in the packets and find the things that you're looking for. It's a really, really big tool and you need a whole course for it. So in this course, we're actually going to use it in a few lectures, just covering the basics or the things that's related to us. So the main idea here is Wireshark is not a hacking tool. It only allows you to capture the traffic that flows through your own computer, through your own interface. I'm going to use it now and it's going to become more clear to you. So I'm just going to go to Kali and we're going to start Wireshark. You can run Wireshark from the command prompt, or you can just go on all applications and type Wireshark and it'll show up right here. I'm going to click that and that's going to load the program for me. This is just a normal error, just ignore this error. And this is the main interface of Wireshark. So first of all, you can actually just go to the file and go to the open. And in here, it'll allow you to open a file that you've already captured. So for example, if you captured packets using a different sniffer, using Aerodump, or using man in the middle F, or using T-Shark, which is the command prompt part of Wireshark. So if you captured packets using any of these programs and you stored it in a file, you can just come in here, open it, and start analyzing that file. This is really handy because sometimes you don't really want to analyze the traffic on the fly. So sometimes you just want to capture it. Sometimes you're capturing from a small laptop, or you're capturing from your phone, and you're not even at home, you're in somewhere else doing your pen test, and then you go back home and then you want to analyze what you captured, then you can store that in a file and then just come here, go to the file open, and open the file that you want to analyze. So what I want to show you here is the idea that Wireshark is not a hacking tool. It's not going to capture things happening in another device. It will only capture things that flow through your own interface. So right here, we can see that we have all the interfaces in my computer. So we can see that we have ETH0, we have any, which is just any, and we have all the other ones that some of them are created by VirtualBox. So the main one here is ETH0, which is the virtual interface connected to my NAT network. And you can see that there is no traffic flowing through this. So you can see that this is constant and nothing's happening. So what I'm going to do now is I'm just going to make this a little bit smaller. And I'm going to open my browser here. And I'm just going to go to a normal website. I'm just going to go to google.com. Now, as you can see right here, you can see the traffic in ETH0 is spiking up. So there was some traffic generated through ETH0. So if we're sniffing on this, we'll be able to capture these packets that were sent over ETH0. Now what I'm going to do is I'm going to go to my Windows machine just to prove that point. And I'm going to browse the website here. And you'll see that ETH0 will not be affected. And the traffic that's generated on this Windows machine, which is in the same network as the Kali machine, it will not be captured by the Kali machine. So if I just go to Google again here, you'll see that nothing happened in ETH0. So there is no traffic flowing through this. It's still constant. And we can only capture packets that go through ETH0. So now you'll probably ask then why Wireshark is so useful. Why are we even talking about it if we can only see things that go through our own computer? Why are we talking about it? Well, we're talking about it because we've seen there is a large number of ways that you can become the man in the middle. Now, we talked about two methods to become the man in the middle. We talked about doing that using ARP spoofing. And if we create a fake access point, then we'll naturally be the man in the middle because all the requests will be sent to our computer. So when we are the man in the middle, if we start sniffing on the interface that's used to become the man in the middle, we'll be able to capture all the traffic generated by the people that we're targeting in our man in the middle attack. So if you started a fake access point, you can start sniffing on the interface that's broadcasting the signal, and you can capture all the packets sent or received to anyone who's connected to that fake access point. If you became the man in the middle using ARP spoofing, then just select the interface that you used when you launched your ARP spoofing attack. So I'm going to do this with ARP spoofing because it's quicker and easier than generating a fake access point. But again, this works in both ways. And it even works if you manage to become the man in the middle using a different method. Just make sure you select the interface that's used to launch that attack. So I'm going to do ARP spoofing. Now you can do this using ARP spoof, or you can do it using man in the middle F. So I'm just going to do it using man in the middle F. And I'm gonna go and just get the IP address of this computer. So it's 10.20.14.206. So our command is gonna be man in the middle F, ARP spoof, interface, which is gonna be ETH0. Then we're gonna specify the gateway, 10.20.14.1. And then the target, which is 10.20.14.206. So we did this command before. This will just put me as the man in the middle. It'll redirect the traffic from the computer that has the IP that's 10.20.14.206 to my computer, placing me the man in the middle. So I'm just gonna run this attack quickly. Now let's go to the Windows machine and see if I do anything here, if it's gonna affect the traffic in ETH0. So we'll see if Wireshark will be able to capture traffic generated by this computer. So let's write anything here. I'm just gonna Google, or I'm just gonna go to a different website. I'm just gonna go to Bing. And if we come back here, you'll see that we have traffic being generated here. And we can see that ETH0 is actually capturing whatever that's happening in a completely different device, and a device that's not even connected to our network. This is happening because when we are the man in the middle, all the packets that's generated by the Windows device is actually being redirected to my own computer right here, to the Kali. And then Wireshark is sniffing that from the Kali machine. It's sniffing it from my own local machine. It's not sniffing it from the network. It's not sniffing it from the target computer. It's only listening on my current interface, which is ETH0, and it can capture packets that's flowing through ETH0 because man in the middle has redirected, man in the middle F has redirected the traffic of the Windows machine to flow through my computer. So again, if you're doing this with the fake access point, then just listen on the interface that you're broadcasting. If you're doing this with a real wireless network, if you're connected to your home wireless network using LAN 0, then you can just do this with LAN 0. But with ARP spoofing, you have to first redirect the traffic, then you can use Wireshark. Now, this is just to show you what Wireshark is and how it works, and I just wanted to stress the idea that Wireshark is not a hacking tool. It's only a program that allows you to log packets flowing through a certain interface and then analyze these packets. So in the next video, we'll see how we can sniff and analyze packets using Wireshark. In the previous video, we seen how we can launch Wireshark, and we said that we can actually just open a file that contains packets that we already captured, and we can start analyzing them using Wireshark. In this video, I want to start sniffing packets and then generate some traffic in my Windows machine, and then we'll see how we can analyze these packets using Wireshark. So I'm already the man in the middle. As I said, you first have to be the man in the middle to use Wireshark. And then the traffic that's generated in the Windows machine is actually flowing through ETH0, as we've seen in the previous video. So before I start capturing the packets, I want to go to the options, and I just want to show you what options we can set. So first, you can see all the interfaces that you have, and you can see the traffic generated on them. And you can see ETH0 is actually generating some traffic every now and then because it's actually coming from the Windows machine, which is already in here. And now anything that we do in here, for example, if we search for anything, you'll see there's a spike coming up here because the traffic is flowing through this. So in here, you can select the interfaces that you want to start capturing on. And you can actually select more than one interface. And all you have to do is just hold the control and then click other interfaces that you want to listen on. For example, we can just click them like this. But for now, I actually only want to sniff on ETH0. Now, if we go on the output, you'll see that you have an option to store these packets somewhere. So again, if you only want to sniff and you don't want to analyze things, then you can just go on the browse and you can store the packets that you're gonna sniff somewhere, and then you can analyze them whenever you have the time at a different time. You can just open them with Wireshark like I showed you in the previous video. You can just go on File, Open, and then open the packets and start analyzing them. Now, I have ETH0 selected, and I'm just gonna click on Start. And that will start capturing packets. Anything that's going to flow through ETH0 will be captured, and it will be displayed in here. Anything. I mean, images, pictures, messages, cookies, anything that that computer does on the internet will flow through ETH0 and therefore will be captured by Wireshark. So it's not like man in the middle life where it was only showing us the important information. Right here, you'll see anything, all the traffic that's generated. So let's first of all generate some traffic here. So we've already generated this, but this wasn't captured. So let's look for something. So for example, let's look for a car. We're just going to look for a car called GTR. Maybe we go on images. You can see some nice pictures. Maybe open one of them. Now let's go back to Bing. And let's go to Dailymotion. Okay, now let's try to analyze the packets or the traffic that we generated. So I'm just gonna stop this. Now this is the main interface of Wireshark, and you can see that the first thing we have is each one record of this is a packet. Now you'll see here the columns. First of all, here is the number of the packet. So you have this one is number 1, number 2, number 3, number 4. In the time, you'll see the time when this packet was captured. So 0 is when we first started sniffing, and then the time increases as we go down, and it shows when these packets were captured, when they were sent basically. You can also see the source. So this is the device that the packet was sent from. And you can see that this one is not sent from our target. It's actually coming from the internet, from a server that has this IP, and it's going to our target computer, which is 10.20.14.206. You can see the protocol, so it's TCP for this one. You can see that it's ICMP in this one, and you can see that it's ARP for this. You can see the length, which is the size, and you can also see info about this packet. Now you can also notice that these packets have different colors. Usually green is TCP packets, dark blue is DNS packets, and if we go down, we should actually be able to find some of them. And you can see all of these are DNS packets. Light blue usually is UDP, but we don't have any UDP packets at the moment. And you can also see that we have some black packets, and these are TCP packets that had a problem, that had issues. Now, if you double click any of these packets, it will display more information for you here. It's the same information that's being displayed in here in the bottom. So if we just bring that down a little bit, you can see right here you have the frame, you have the Ethernet, the Internet Protocol, and the Transmission Control Protocol. And using that, you can just click on the arrow and then you'll see more information that's stored in here. Now again, if you just double click the packet, you'll get the exact same information, and you'll be able to get information about the packet that you just selected. Now what we did on the target computer so far, most of the traffic that we generated was HTTP traffic. So to get rid of all this information that's hard for us to read, we're just gonna type in here in the filters, we're just gonna type in HTTP. Hit enter. And as you can see now, that filtered all the packets to HTTP traffic only. So for example, right here, you can see that we have a post request send from our target computer to a server. We still don't know what that server is, but to a server on the internet. And when we double click that, we'll get more information about this packet. I'm gonna make this smaller here. So on the frame, you can see that the interface that's used. You can see information about the packet itself. In the Ethernet 2, you'll see information about the destination and the source, so you can see that the MAC address is used. In the Internet Protocol, you'll see information such as the geolocation of the target, so we can see that this packet is sent to the United States. In the transmission, you can see information about the ports used. What really interests us is the Hypertext Transfer Protocol, and this is where you really see the interesting information in our case. So in here, you can see that the request was sent to bing.com, and you can see that this request was searching for www, and you can see that the content type was a text. So you can get this information about each packet that's sent. So you can see that Wireshark logs everything that happens. It doesn't only log, or it doesn't only show the interesting stuff. It literally logs everything. So it contains the interesting stuff plus much more. Now, if we go down, we can see that we have another post request. And if we double click that, it's probably going to be my second search, which is when I search for the GTR. And you can see here, I searched for a car and it's called GTR. So again, right here, we can see all the searches that we did. We can see all the URLs that the user entered so far. And if we go down, you'll be able to see all the other URLs that we visited. So you'll be able to see Google and Dailymotion as well. In this video, we'll see how to use more Wireshark filters and capture a username and a password. And also we'll see how to see the cookies of a person if they're already logged into a service and they didn't enter their username and password. So I'm going to start a new capture. I'm going to close this without saving. And I'm going to remove this filter from here. And I'm just going to go to Hotmail. And I'm going to log in with my username, which is zaid@hotmail.com. And then I'm gonna put the password, which is gonna be a random password, but it's gonna be captured. So we're gonna put 123456. Hit enter. And as you can see now, we managed to capture traffic. I'm gonna stop this. And I'm going to look for HTTP. And we're gonna look for post requests. So we can see here we have get. These packets are sending get requests, and we're gonna look for something that's sending a post request. And you can see now this is the first one sending a post request. So it's being sent from the target computer to the server. So let's double click this and see what's inside it. And looking right here, you'll see that this was sent to login.live.com. But we can't see any username and passwords in this one. So I'm going to close it. And I'm going to look for the next post packet, which is this one. Again, double click it. And let's see what's inside it. Now, if we come here to the HTML form, you'll see that we have the login, which is zaid@hotmail.com. So this is what we entered. And you can also see the password, which was sent as 123456. So again, man in the middle left was doing this very easy for us, and it was showing us the information easily. It was filtering the important information for us. But right here, we can see that we can actually capture anything that's sent on the network, and we can see it using Wireshark. Another thing that you can do is you can actually search through these whole packets. So you can just go to edit and then go to find packet. And right here you can select if you want to search in the packet list, which is just this, or in the packet details. So we're actually going to search in the packet details. We're going to keep this narrow and wide. And right here, I've set this to string, so you can actually put a display filter if you want, but I'm searching for a string, which is just a normal text. And if we search for Zaid, it will actually go straight to the packet, this packet, which contains my username. And again, if we just look at it here, or we can double click it, whichever is easier for you, you can see that we managed to capture the username, which is zaid@hotmail.com. Now you can do find next, and you'll get the next one. Find next, and again, it will find the next one, which actually had my password in it. So again, the search right here is really useful function that will allow you to navigate through all of these packets and find what you're looking for. Now let's start a new capture and see if we can actually capture the cookies. So I'm going to, again, continue without saving. I'm going to go to my Windows machine, and I'm going to go to Dailymotion, which I already logged in before. And as you can see, it's not asking me to log in because I've already logged in, and it already has a name here. So I'm just going to go to this channel. Now it's just a fake channel that I created just for this lecture. Now, if we go to our Wireshark right here and stop the capture, and look for, instead of HTTP, we're going to look for http.cookie. So if we go down, you can see that right here the person got to their homepage, which is that's the username, the fake username that I had. Now if we go to the post request before that, and look at the hypertext, you can see the cookie that was sent to authenticate that person. So if you use, you can just download a plugin for your browser and inject these cookies into that browser. You'll be able to log in to that username, to that account, without using the password, the same way that the user entered. So this is the same that what we did with Ferret and Hamster. Again, I'm just doing this to show you that Wireshark can be used to do all of the attacks that we did before, plus much more, because basically it can capture anything that flows through our device. So any request sent or received to or from the target computers will be flowing through our interface, and then Wireshark will be capturing anything, regardless of whether it thinks it's important or not. It's going to capture everything. So it's a really, really handy and useful tool. Right, so let's talk about how we can detect ARP poisoning attacks. First of all, let me show you the ARP table. So in our Windows device, which is the device that we always attack, I'm going to run a command, ARPA, to list all the entries in the ARP table. So each computer has an ARP table, and that table associates IP addresses with MAC addresses. So we can see the IP address of the router, which is 10.20.14.1, is associated with the MAC address 52.54, and it ends up in 35.00. So this is the MAC address for the IP for the router. So the way that ARP poisoning works, like we discussed before, is it works because each request is trusted, and clients accept responses even if they didn't send a request. So what the hacker does is he sends a response to the client, telling them that they are the router. So the client will accept that, it will trust it, and it's going to accept the response even though it didn't send a request. Then we'll send another response to the router, telling them that we are the client. So what this is going to do, it's going to modify the entries in the ARP tables in both in the router and in the client. And for the client, it's going to contain the hacker's MAC address, and it's going to associate that with the router's IP address. So what's basically going to happen is it's going to modify the MAC address here, and it's going to change that to the attacker's MAC address instead of the router's real MAC address. So when that happens, then the hacker will be in the middle of the connection, and they'll be able to read, analyze, and modify the packets because they're going to be flowing through the hacker device. So let's run the ARP poisoning, a normal ARP poisoning attack like we always do it. And when I go back here, I'm going to execute the same command. So I'm going to do an ARPA again. And note how the MAC address is going to be different. So the MAC address for the router, it used to be this one. And when we ran the command, then the MAC address changed to this one. And this MAC address right here is the MAC address of the network card that the attacker is using. So if I come here and just do an ifconfig, you'll see that this is the MAC address, the same MAC address that is displayed in here. So this is the easiest and the simplest way to discover ARP poisoning attacks. It's not the handiest way though, because you're going to have to keep doing this command and keep comparing the entries if you really wanted to check if you're being ARP poisoned. So there's a tool called XARP, and it does that automatically for you, and it's available for Linux and Windows. So I already downloaded. You can just Google XARP and you can download it. Very easy to download and install. And I'm just going to run it. I'm actually going to stop the attack first, and then I'm going to run the tool. Now notice when you stop the attack, the IP address is going to go back to what it was. So you can see that the MAC address of the router is back to its default right value of the router. So I'm just going to run xarp now. And you can see that everything is good. And you can see that the entries are very similar to what we did when we did ARPA. So we have the IP addresses and the MAC addresses associated with it. What the tool basically does, it's just going to automatically monitor this. And whenever something changes, it's going to know that something's wrong is happening, because each IP address should have a unique MAC address. There should be no duplicates in the network. So I'm going to do another ARP poisoning attack, exactly like we did it before. And when we come here, you'll see that xarp is giving us a notification and telling us that something's happening. It's telling us that the MAC address for the router, which is the 10.20.14.1 IP, has changed from this to that. And if we look here, I'm going to click OK. And if we look here, we can see that the affected machines are the router, my own machine right now, and the attacker. Sorry, that's me, and that's the attacker. So basically, we know that the machine at 10.20.14.203 is trying to do an ARP poisoning attack, because it's the one that the router's MAC address has changed to. Therefore, we know this is the attacker machine. So this tool is really handy because it does the monitoring automatically for us, and it will tell us whenever someone is trying to ARP poison the network. Okay, so now let's see how we can use Wireshark to discover suspicious activities in our network. And before I do anything, I'm going to go to the preferences. And I'm going to go to protocols, ARP. And I'm going to enable the option to detect ARP request storms. What this will do, it'll actually discover if anybody is trying to discover all the devices on the network, and it's going to give me a notification. So I'm going to click on OK, and I'm going to start my capture. And now I'm going to go to my Kali machine, and I'm going to use net discover. So I'm not going to do ARP poisoning. I'm only going to try to discover all the connected devices to my network. So we're using exactly the same command that we used before, net discover, interface, and the range. I'm going to hit enter. And we can see that net discover finished. It discovered all the devices that we have. So if we come here, even before we look at the output of the notifications, let's just look at the packets that have been generated. You can see that there's a device here. This source is broadcasting, so basically it doesn't have a destination. It's asking all the other devices in the network, and it's inquiring about each possible IP. So it's basically asking who has this IP and tell the 67 IP. And then it's asking who has the 241 IP, tell the 67. Who has the 251, tell the 67. And it's doing this for every possible IP. So it's basically checking if any possible IP in the range exists, and it's asking to return the response to the IP at 10.20.14.67. So from this, we can deduce that someone is trying to discover all the connected devices, and that someone is at 10.20.14.67. Now, if we go on the analyze and expert information, you'll see that we detected an ARP packet storm. So basically it means that there was a single device sending a very large number of ARP packets. So they're probably trying to discover connected devices or trying to discover connected ports. So it's telling us that this person is trying to do something suspicious. Now let's go, and I'm gonna do a ARP poisoning attack using man-in-the-middle framework, and we'll see if we can get any notifications or warnings in Wireshark. Now I'm gonna go to analyze and expert info again, and if we look, we'll see we have a warning here, and the warning is telling us that there is a duplicate IP address configured. So again, this is telling us that the IP address of the router had two different MAC addresses. What this means, basically, it means that someone was tampering with this and tampering with our ARP table, trying to place themselves in the middle using an ARP poisoning attack. Now, we've seen a number of methods to detect ARP poisoning. Let's discuss how we can prevent it or protect ourselves from it. Now, I'm just going to run an ARPA, and we're going to look at our table. There is switches that will monitor this for you as well, and they'll notify you or even prevent ARP poisoning attacks. Another way to do that is, if you look at here, if you look at your router, you'll see that this entry in the table is dynamic. So the type of this entry is dynamic. What that means, it basically, this can change. It's the system allows this value to be changed. You can see right here, you have static values, which basically means the system will never allow these values to change. So you can use static ARP tables, which basically means that you'll have to configure each IP address. So you have to actually configure your ARP table and map each IP address to the MAC address, to the relevant MAC address. But once you do that, even if someone tries to send a response to your computer trying to change it, the system will refuse to change anything because you configured your ARP table to be static. The only problem with that is every time you connect to a network and every time there is a new device connecting to your network, you'll have to manually configure that device to work with your network. So it's not a very useful solution if you're in a big company or if you're in a big firm, but maybe in a small house or in a small company, then this would be a really good solution to prevent ARP poisoning attacks, because everything is going to be static. You're going to have to set it up manually. But when someone tries to do an ARP poisoning attack, even if their attack is successful and they use the best tools they can, your table is set up in a way that it's fixed. It can't be changed. So the system will always refuse to change the values of the MAC addresses, which will basically mean ARP poisoning attacks will never work against you.